me just see if I can set this screen up so we can see both information that is being presented. Come on. All right. Go back to the Zoom. Where is it? All right, so we should be able to see that. Let me see if I can get the, oh no, I'm not getting it. The time player. Where is it? Bear with me a moment.
Oh no.
All right, so let me see if I can get this up and running now. Where's the PowerPoint? All right, so that's there. All right, guys, can we confirm if we can see both screens quickly, please, before we move on? All right, can we confirm quickly before we move on? Can we see both screens? No answer, Pastor?
No, just relations, functions, and graphs.
I don't know what's happening with that. All right, so all right, so I'll move on. Can I have a volunteer to monitor the chat for me? Because of how I'm presenting the screen, I'm not able to see what's happening in the chat. The last time, I think a young lady by the name of Amanda, is she here? Or can I have another volunteer quickly before we move on, so to monitor the chat? Anybody to monitor the chat? Can I have a volunteer? Who's that?
Rochelle.
Okay, Rochelle. All right, Rochelle, I'm going to ask you to monitor the chat for me, please. Thank you so much for volunteering. All right, so the last class we did functions, relations, and graph. Our focus question for this unit is what are relations and when is a relation a function? Now, a relation is a set of points or pairs of input and output values. A function is a relation in which each input corresponds to only one output. So a function can only have one input and one output, while a relation can have many. So what is a relation? A relation is a set of ordered pairs. And as we said earlier on, these are what the ordered pair looks like. 1, 2, -1, 3, -2, 5. These are in brackets or braces. So these are what are called relation. Now we have two types of relation. One is a function on the left, and the other one on the right is not a function. This is what makes the one on the left a function, due to the fact that we said that a function has only one output, one input, and one output. And if you look clearly on the left, you have 1 going to B, 5 going to A, and 8 going to B. Well, you might be saying, how is it that 1 and 8 is still going to be and it is considered a function? It is considered a function because only one value in the domain is going to only one value in the range. Whilst if you look on the left, this is not considered to be a function due to the fact that 5, which is one input, is going to 2 different outputs. So that's the difference between the one on the left and the one on the right. Now, also what you need to know in functions is that when we talk about input and output, we're talking about the domain. Another name for it is the domain. which is the input, and the range is the output. I liken that to the fact of you going to an ATM machine. The ATM machine is there. Your input is your debit card, and the output is the money that you get. And the machine there will have to process whatever you put in. So that's considered to be an example of an everyday function. Now, there are different types of relations. We have one-to-one, we have one-to-many, we have many-to-one, and we have many-to-many. Sorry about that. All right, gonna have a quick icebreaker before we move on. I'm gonna give you a minute just to get the icebreaker going, and then we'll move on. All right, so here's the icebreaker. John has been hired to paint the numbers 1 through 100 on 100 apartments. How many times would he have to paint the number 8? So let me say that again. John has been hired to paint the numbers 1 through 100 on 100 apartments. How many times would he have to paint the number 8? I'm going to give you a minute to do that, and then we'll get the responses. Rochelle, you're going to tell me the responses in the chat, and then we move on with this unit. All right, so go ahead.
Okay.
All right, guys, go ahead. Your minute has started. Oh, I thought I had.
Someone said 100. Shante.
I'm gonna give you a minute.
Shante, Alan said 100. Someone else said 9 times. Danielle said 100.
All right, let's see if we can get some answers in. Rochelle, are there any answers in the chat?
Yes. Shante said 100.
Rochelle,
Hallie?
not hearing you.
Not hearing me? You're hearing now?
All right, guys, not hearing Rochelle. If you're able to unmute, you can go ahead and unmute and share your answers, then we move on. How many times would he have to paint the number 8?
100.
Individuals are talking, but I'm not hearing. Just go ahead and unmute.
100.
19.
I'm hearing
9 times.
a lot of individuals are talking, but I'm not hearing. So is it that we're having a
All
technical
right,
problem? Is it that we're not unmuting our microphones?
Brother Brown, are you hearing me?
Not hearing.
Are you hearing me, Brother Brown? Sister Murray here. Are you hearing me?
Not hearing. Not hearing all these individuals who are talking. All right. Let me see. Not hearing anyone.
2 persons said 100. Got that?
100.
All right, so the answer to that icebreaker would be he would have to paint the number 8 at least 20 times.
What?
All right, so we're going to be looking at a few examples, but before I move on, I need to ensure that I'm able to hear you. Rochelle, can you just confirm? Can you just unmute your microphone, say something so that I can hear?
Hello. You hearing me now? You hearing me now, sir?
Hearing. Are you guys hearing me?
Yes, we are hearing you.
Yes, everybody's hearing you, but you seem not to be hearing
us.
Okay, brethren, I am trying to communicate to him by text. Obviously, he's not hearing us.
So let me check the microphone. Everything is off. All right, so I think I'm here. Okay. Yeah, I'm hearing now. I think because I don't know what was happening. All right, so let's move on. All right, let's move on. Which of the following set is represented by the relation f is mapped on to x squared minus 3. These values on the left, these are considered to be your input, and these values on the right, these are considered to be your output. Now, whatever you put into this machine, the result will be your answer. Can we mute your microphones, please? All right, so okay, so let's move on. All right, so we have now, we're gonna put 0 into this function, this relation to get our results. So if we square 0, we're gonna get 0, and 0 minus 3 will give you -3. Let's try another value, 1. 1 squared is 1, and 1 minus 3, that is -2. -2. Then now let's put 2 in. 2 squared, that's 4, and 4 minus 3 is 1. So it therefore means that A is our answer. We put all these numbers, which are our input, and we get our values or range, which would have given us A as our result. All right, in the diagram above, it represents the relation. Guys, I'm getting too much feedback. Can we unmute? Can we mute our microphones, please? All right, so the diagram above represents the relation. We need to look at the diagram above. We have 2 going to 8, 2 going to 10, and 2 going to 12. We have 3 going to 12, 4 going to 12. We have 5 going to 10, and we have 6 going to 12. Which information below best suit this information up above? So is X a multiple of Y? Is X a factor of Y? Is X greater than Y, or is X divisible by Y?
X is a factor of Y.
A?
I say B.
B, X is a factor. Any other answer?
X is a multiple of Y.
X is a multiple of Y. All right, let's look at it. So remember now, look at where the arrow is pointing. 2 is pointing to 8. Is 2 a multiple of 8, or is 2 a factor of 8?
Factor.
2 is a
Factor.
factor. Yes, 2 is a factor of 8. 2 is also a factor of 10. 2 is also a factor of 12. So it's not a multiple, it is actually a factor. So X is a factor of Y.
Mistake.
No problem, we all made them. All right, so next question. The relation diagram shows above represents a function. Which of the following equation best describes the function? All right, so we have our diagram here. 2 be mapped onto 2, 3 mapped onto 4, 5 mapped onto 8, and 7 mapped onto 12. Are these values equal? This is saying f of x is equal to x. These values are not equal, so A is out. F of x is equal to y. These are also saying that these are equal. A and B are definitely out. So we're using the elimination process to eliminate answers. So A and B are out. Let's look at C and D. These are the values in our x, 2, 3, 5, and 7. We're going to substitute them in this function. Wherever x is, we're going to put these values right here. So if we put 2 right here, it will be 2 minus 2. And we know that 2 minus 2 will give us 0. However, 2 is not mapped onto 0. Do we see that?
Yes.
Yes, 2 is mapped onto 2. So that means that C is not correct. So A, B, and C are out. So it therefore means that these are answer. Even though we know that these are answer, let's prove it. All right, so let's put X right here. Let's put our value. Let's put a value. Let's choose 3. We're going to put 3 right here. 3 minus 1, we know that's 2. And wherever we see parentheses or wherever we see brackets, it means that we multiply. So 2 times 2 will give you a result of 4. So it means that that is definitely correct. We have proven it. We have not just selected our answer, but we have also shown a proof. All right, let's look at this one. The arrow diagram above describes the relation. Let's look at the values, the domain and the range, the input and the output. So 8 is mapped onto 2, 8 is mapped onto 4, 9 is mapped onto 3, and 10 is mapped onto 2. Which
X
of
is
the
a
answers?
multiple of Y.
Multiple?
Yeah.
Do we agree? Do we all agree?
No, sir.
Anyone else? All right, so that is indeed our answer. Our answer is X is a multiple of Y. 8 is indeed a multiple of 2. 8 is also a multiple of 4. 9 is a multiple of 3. Likewise, 10 is a multiple of 2. All right, so that was mainly on relations. Now we're going to be looking at functions. And as I said, a function has only one input and one output. That is what makes a function a function. Simple as that. All right, now sometimes in the examination, you will be given graphs and you'll be asked to prove if these graphs are function. Now, a very simple way to do that is what is called our vertical line test. Now, the vertical line test is where you're going to draw a vertical line up and down. You're going to draw a vertical line. And if that line intersects with more than one of the values, it means that it is not a function. So let's look at these examples here. We have 6 examples. What do I mean by that? Now, let's look at this. The red lines, the red diagrams, they represent functions. And the yellow line, they represent the vertical test that we're doing. So let's look at the first one. Can we mute our microphone, please? All right, so let's look at the first one. So this is our function. And if we draw any line, if we draw a vertical line through it, it only intersects at only one point. So it means that this is a function. Let's look at the second one. The second one, this is a function. Well, let's test if it's a function. This is our diagram, and we draw a vertical line through it. It intersects at 2 points. Here we see it. So it means that if it intersects more than 2 points, it means that it is not a function. Remember, a function has only one input, one output. So when it touches the graph only once, it means that it is a function. That's all the vertical line is saying. The vertical line test is saying. So we're going to look at some examples of the vertical line test. All right, so these are some examples. Which of the following is not a function? Which is not a function? You can draw vertical lines. You can even make mental lines, and then you will see which one is not a function. Which one will touch the point?
B, sir.
B?
Yeah.
Yes. If you do a vertical line test right here, these will be 2 points. It means that B is not a function. Very good. Which of the following diagrams is the graph of a function? Remember, though, you have to read the question carefully. The first one says which one is not a function. This one says which one is a function.
D.
B.
D. D.
B as in boy?
No,
D
D
as
as
in
in dog.
Oh, D as in dog. Yes. Yes. And guys, don't get nervous or don't get anxious because of how the function looks. This is indeed a function. It doesn't matter how it looks. Once it passes the test, it is a function. So if you do a vertical line test at D, it only touches the point, it only intersects once. So it means that D is indeed a function. Very good, guys. Which of the following diagrams is the graph of a function? Again, which one is a function?
C.
C. All right, let's test. If we do a vertical line right here, it means that it's going to touch it 2 places, so that is not a function. If you do it at B, it will not be a function, likewise D. So yes, your answer is indeed C. If you do one line through the entire, if you do a line anywhere in the graph, it will only touch 1 point. So it means that C is a function. All right, good. And that's basically that for the vertical line test. Now we have in functions where sometimes we'll be asked to substitute values, and we're also have what is called our composite function. Now, substituting values, of course, is where you take a value and you put it to replace, just like playing a game, a football game or a netball game or basketball, where a player, if someone goes off the field, that individual takes that person's place. That is what substituting is all about. It's replacing. Now, a composite function is when you take an entire function and you put it in place of that function. All right, so we're going to be looking at an example of both concepts. Given that f of x, and whenever we see this, you read it as f of x. Given that f of x is 4x minus 7, and g of x is equal to x squared minus 15, calculate the value of F3. And the second part says we're to calculate G f of 2. I'm not sure if we are seeing, are we seeing the whiteboard on the left here that I have? I am actually writing. Can we confirm, Rochelle? Can we see it?
No, sir.
No?
No, sir.
No,
All right.
can't see it.
Let me redo this. I don't know what's happening with no. I don't know why we're not able to see it. All right. Any success?
No, sir.
Give me a minute. I don't know what's happening. Why? Last time that's what I did. New share. Okay. Can we? No, it's not there. Can we see it?
Yes, sir.
All right, good. Finally. All right. So we have f of x, which is 4x minus 7, and we have g of x, which is x squared minus 15. Now we're asked to find f of -3. F of -3, it means that we're gonna put this value where x is in this function, which is 4x minus 7. So we're gonna put -3 right here. So it's 4 times -3 minus 7. So all we're doing is substituting this -3 where x is. Remember, parentheses or brackets, it means that we multiply. So 4 times -3, that's -12. And -12 minus 7. Whenever you have negative numbers, I'll tell you that you can think of it as owing. So you owe $12 and then you owe $7. How much do you owe in all? What's our result?
$19 at -19.
-19, good. So whenever you see a negative, just think of owing and then you won't have a problem with saying, is it a +19 or a -19? Whenever you see negative, just think of it as how much you owe. So the result for this function will be -19. All right, let's look at the second part of the question. The second part of the question asks us to find g f of 2. All right, so g f of 2. Remember I said this is considered to be a composite function, and a composite function is where you take one function and put it into the next function. So the function that we're going to take the function that's always on the outside. That is the function that goes on the other in the other function. We're asked to find g f of 2. We don't know what f2 is, so it means that we have to find f2 first, and when we get that value, we put it into g. This is our function f, 4x minus 7. We're gonna put 2 where x is. So we're saying 4 times 2 minus 7. 4 times 2, that's 8, minus 7, which is 1. So the result for f of 2 is 1. We're gonna take 1 and we're now gonna put it into g. Do I have everybody's attention? Do we get that so far?
Yes, sir.
Yes, sir.
All right, good.
Yes.
So f of 2 is, we put 2 where f is. Sorry, we put 2 where x is. So 4 times 2, that's 8. 8 minus 7, that's 1. Now that we get a result of 1, we're going to put it in this function, g, right here. And we know that the function g is x squared minus 15. We're going to put 1 right here. So it's 1 squared minus 15. Whenever you square a number, you're multiplying that number by itself. So 1 times 1, that's 1 minus 15. What's our result?
-14.
-14. Good. All right. Very good. Any questions so far?
No, sir.
All right, so I think we're good so far. All right, very good. All right, let me see if we can move on. Are you just seeing the whiteboard or you're seeing both screens?
Whiteboard.
Just the whiteboard. All right, so I'm still having that problem. All right, let me see if I can get this done. Sorry. Come on. All right, sorry about that. All right, back to that now. Can we see that clearly?
No, sir.
No, we're not seeing, you're not seeing the presentation?
No, sir.
I don't know why I'm having so many problems today. Any, still not seeing it. Any success?
No, sir.
No. Why am I having so many technical difficulties today? All right, let me, screen has been stopped. Okay, all right, so the screen I didn't share. Okay. All right, we should be back now.
Yes, sir.
All right, good. All right, so now we're going to be looking at some graphs, and there are some things that I need you to remember when we're looking at graphs. Remember, we have the domain, which is our input, and range, which is our output. The equation of a line, normally you're given it in this form, y equals mx plus c. Do we remember that? Do we know of doing that? Y equals
Yes,
mx.
sir.
All right, good. Y equals mx plus c, that's the general form that you'll be asked to write an equation in, where m represents the gradient, and another word for gradient is slope, and the slope is basically the rise over the run. And c, which is the y-intercept. When we talk about the y-intercept, we're talking about where it cuts the y-axis. So y equals mx plus c, m is our gradient, and c, which is right here, that is our y-intercept. All right, so let's look at an example to help you. The diagram below shows the graph of a straight line passing through the points A and B. And if you can look clearly, you see A right here and you see B right here. Now, a few things to remember what we just said. Y equals mx plus c, that's the general equation, where m is our gradient and c is our y-intercept. And y-intercept refers to where it cuts the y-axis. This is our y-axis. This is our x-axis. The first question we're asked is, the equation of the line above is y equals mx plus c. State the value of c. So let's assess the graph. Remember, we said that c represents the y-intercept, which is where it cuts the y-axis. If this is our y-axis, can someone tell me the value where this line cuts the y-axis?
4.
4?
0, 4.
Yes, sir.
So they said 4.
4? Okay. All right. So even though you don't see any values, if you look clearly, you would have seen 5 here, you would have seen 5 here. So it means that if this is 0, we are counting for 1 unit. So 1, 2, 3, 4. So it means that the value for C is 4. Good. Then now you're asked to determine the value of, M. And remember now, M is our gradient. Now let's look at the line. A is at the top and B is below. Is this graph going upwards or is it going downwards?
Down.
It's going
Downwards.
down. It's going down. And whenever a graph is going down, it means that your slope will be a -1. If it were going up, it would have been positive. So once it's going down, that's a negative slope. All right, so first of all, you know that your answer will definitely be negative. Now remember we said that slope is rise over run. So let's see how many units. Let's see how many units we go down. So you can make like a right angle triangle and you can actually see a triangle being formed right here. Or if you had wanted to do it on the outside, you could do that. So we're gonna count our units down. So that's 1, 2, 3, 4. Once we're going down, that's a -4. And then we go 1, 2, 3. So it therefore means that our slope is -4 because we move 4 units down, 1, 2, 3, 4, and then 3 units across, 1, 2, 3. So it means that our slope is -4/3. Are there any questions as to how I got the slope? Because there are a lot of graphs that you will, there are quite a few graphs you will get in the examination. We're good? All right, no answer, so it means we're good. All right, there will also be questions in terms of these types of graph where you're going to be asked to like state where the shaded area of the graph represents. Now, there are a few things that you need to know. Whenever you have like a dotted line, it means that the value is included, dotted or solid line. So this line would be considered a solid line. It means that the value is included. And when a value is included, we use this symbol, less than or equal to or greater than or equal to. When you have a broken line, it means that that value must not be considered a part of your solution. So let's look at this question. It says the shaded area in the graph above can be represented by, first of all, before we answer, let's assess the graph. Let's look right here. This is a solid line going through +1 on the y-axis, and there's a broken line going through -2 also on the y-axis. Which of the answers would be, which of these would be our answer? A, B, C, or D?
C.
Is it D? Wait,
D?
I think so.
Which one you say, D?
I think it's C.
C.
I think C.
Okay, all right. All right, so let's look. So this is -2, and it's on the y-axis. And remember, the broken line means that it is not included. Broken lines mean it's not included. So when it's not included, we use this symbol. A doesn't have that. B has it, but this has a solid line. So it means that this must be using this symbol. So B is out. So your answer is between C or D.
Answer is D.
D?
Yeah.
All right, so someone says C, someone says D. Let's see which one is the correct answer. All right, so let's look at C. It says 2 is less than y, which is also less than or equal to +1. And D says -2 is greater than y, which is also less than and equal to 1. Would we say C or would we say D?
C.
C. Who, the person who said D, are you still saying D or you're saying C now?
I'm saying C now.
C. Okay, so the value is less than. So yes, this is unbroken, so it's not included, and this is solid, so it is included. So definitely, let's look at it. This means that the value is not included. This means the value is included, and this is on our y-axis. The numbers are between -2 and +1. So your answer is indeed C. Question? You have a question? We have a question? No? All right. You will also be getting some questions where you have graphs, and you're going to have to look at the curve and assess the given graph. Now let's look at this example. I'll be asking 3 questions based on this graph. And if you clearly look, this graph is a curve. 3 questions now. What is the coordinate of the turning point? Now the turning point refers to that point where the graph begins to curve. Where would be?
Is it 0 and -4?
0 and -4. So you're saying 0. And when you have your ordered pair, remember it's always X first and then Y. So you said 0 and -4, which is this point, right?
Yes, sir.
We mute our microphone. All right, so it's 0, -4. Yes, you're indeed correct. At this point, the graph, it started to curve right here. So that is what is called our turning point. Very good, that's correct. Second question, the values of x for which x² - 4 intersects y equals 0. What this simply means is this graph, wherever it cuts the y-axis when, sorry, it cuts the x-axis when y is 0. So this is 0. Where are the 2 points on this graph where the curve, it cuts the x-axis? What are those 2 values?
-2 and
+2.
+2.
Very good. So these 2 values are -2 and +2. So that's all that this question is saying. The values of x for which this function when y is 0, you know that this is your y-axis, this is 0. So these are the 2 points. These are the 2 points where there was no movement and it cuts the x-axis. Final question. In the graph above, when y equals -2, the values of x are, let's look at the graph. This is our y-axis. This is -2. We need to find the values of x. So if this is -2 and we need to find the values of x, we need to look on both sides. So we need to go over right here. So we need to know this point, what this value is. And if you on the right as well, we need to know what this point is. What will be your answer? Is it A, B, C, or D? And the plus and the minus that we see there, it refers to positive and negative.
Would it be D?
D?
I can't see the options.
Can't see the options. All right, so the options are 1.2, 1.3, 1.4, and 1.5. So someone is saying A, someone is saying D. All right, let's look at the graph. All right, so the graph, this was our graph, x² - 4. The points for -2 would be -1.4 and +1.4. So it wasn't A and it wasn't D, it was actually C. Let's look, this is -2, this is our value right here. So if this is -1, this is -1.2, -1.4, -1.6, -1.8, and then +2. So you have to look at the smaller units as to how much they value. So the answer here would definitely be C. All right, so we're almost finished with this unit, and then we're going to be looking at some past, the 2019 past paper. So we're going to be wrapping up on this unit now. Basically, all that we have done for functions. Which of the following relation diagram illustrates a function? You can go ahead and share your answer. Which of the following illustrates a function? Remember, we said that a function has one input, one output.
C.
C. All right. Anybody else confirm? Rochelle, are you getting answers in the chat? Is Rochelle still there?
Yes, most persons are saying C.
C, okay. All right, good. So C, this value is going only to 1. This input is going to 1 output, and this value in the domain is only going to 1 value. So C is indeed a function. D couldn't be it because this value is not going to anything. Remember, you can't have 1 input going to 2 outputs, so this is not a function. Likewise, this. You can't have the values like this. So C is indeed your answer. All right, let's look at this question. Which of the following graph is that of a function? Remember now, whenever you have a graph, what do you do to test if it's a function? Anybody can remind us?
Draw 2 lines.
Vertical line.
Yes, do the vertical line test. So if you do the vertical line test now, which one will be a function?
A.
A.
A. Yes. So just see if you know what to do, you know definitely that A is a function, because if you do a vertical line test, it only touches the point once. So that is why it is considered to be a function. Very good. The relation diagram above, what does it represent? Let's look at the relation above. Is it a one-to-one? Is it many-to-one? Is it one-to-many? Or is it many-to-many? Let's look at the diagram. 0 going to 0, 1 going to 2 values, then you have 4 going to 2 values, then you have 9 going to 2 values. Is this a one-to-one? Is it many-to-one? Is it one-to-many, or is it many-to-many?
Many-to-many.
Many-to-many?
One to many.
Many to one.
Many-to-one?
One-to-many.
One-to-many. So I'm getting 3 different answers now. All right, let's
One
go.
too many.
One-to-many. Let's assess the diagram. 0, which is 1, is going to 0. All right, so that's one-to-one, but that doesn't satisfy everything. 1, which is 1 value, how many values is 1 going to?
2.
2, so it's 1 to
Many.
Many.
1 to many. Good. Let's look at 4. 4 is only 1 value, and how many values is it going to?
2.
Going to, yeah, which is considered to be many. So it is a one-to-many relationship. Mm-hmm. All right, let's look at this graph. Sometimes you can get graphs like this, which is on the graphs and inequalities. The graph of the inequalities shown is described by, before we even get to this, do you remember what the solid, when we say that it's like a solid
Shaded.
point, or shaded, is it included or not included?
Included.
The value must be included. So you're looking for an answer that has -3 and
B.
A.
Hold on. Remember, if it is included,
it is less than or equal to.
If it is included, you use the symbol, yeah, less than or equal to, or less than or equal to. Very good. So at least you remember that. So it means that our answer would be
B as in boy.
B. Okay, yes, look at these two. These two symbols, it means that it's less than or equal to. So it definitely would be B. Very good. All right, let's look at another one. In the graph above, the shaded region, what does it represent? Go ahead and assess the graph. Remember now, these are solid lines, and whenever it's solid, it means that it is less than or equal to or greater than or equal to. In this case, it is less than or equal to. So both, look at the responses, both of them, they're solid, so both of them must be less than or equal to. A. All right.
Yes.
Which of the lines does it go through? Does it go through the y-axis or the x-axis?
The Y.
The Y one to answer C.
It goes through the y-axis. So guys, you have to look carefully. Look at A and look at C. They look almost the same, right? Yes, they look almost the same. The only difference between them is X and Y. So you have to look carefully at the graph. This graph is showing that the values are going through the y-axis. So that is why it's C and not A. All right? All right. Which of the following set is represented by the relation F is mapped on, F is such that X is mapped onto X cubed plus 1. Now, when you cube a value, it means that you're multiplying that value 3 times. Remember now, these are our input, these are our output. So let's go ahead and, so the inputs are 0, 1, 2, and 3. Let's find out what our output will be. Now, if you cube 0, meaning that 0 times 0 times 0, you're definitely going to get 0. And then you add 1, which would be 1. Let's choose 1. When you cube 1, which is 1 times 1 times 1, you still end up with 1.
The answer is B, sir.
1 plus 1, which is 2. Okay, you're saying what, B?
Yes, sir.
B.
All right, yes. So we got 0 and we got 1 and 2. Let's check if B is indeed the answer. Let's put 2 inside now. What is 2 cubed?
8.
8. And 8 plus 1, that's 9. So definitely we're seeing that B is our answer. 3 cubed, that's 27.
27 plus 1, 28.
Good. Very good. So your answer is B. And it's always good so you can work out all of them because there are sometimes the answers will be so close that you're deciphering which one is it. So very good on that one. All right, so this is like what we just did earlier on. If f of x is equal to negative x squared plus x minus 1, then what is f of negative 3? This is where you're substituting negative 3 in the given function. So the given function is negative x squared plus x minus 1, and you're to do f of negative 3. Yes, do I get an answer?
A.
A. 5.
Positive 5.
Positive 5. And anybody has got a different answer?
I got D, sir.
B, negative 5.
D.
D, negative 13. Okay. All right. Anybody else?
So D.
All right.
Sir, D.
D. Are we sure? Is it A or is it D?
Sir,
It is A.
Sir, D.
A.
You have to look at the
It is
sign.
A.
All right.
It
So
is
let's
A.
confirm. You have to, who said that? You
It's
have to
A.
definitely look at
Me,
the
sir.
sign. Very
Davia.
good. You
I
have to
got
look at
B.
B. So someone got A, somebody got B, somebody got D. Let's find out what our answer is. Let me see if I can get this thing back up because I don't know. The whiteboard is not working for me today. Where is it? I'm not finding the quick time. Give me a minute, guys. I don't know what's happening today with the where is it? No, not there. Not seeing it. All right, we're still not seeing that screen coming up. Where is it? It's not down here. Oh, there. Oh, okay. All right, let me see if we can get this up. All right, can we see that? Can we see that?
Yes, sir.
All right, good. I'm gonna see if I can, I'm probably gonna have to, I don't know what I'm gonna have to do to get this working because it was working well the other time. All right, so f negative 3, we have negative x squared plus x minus 1. We're gonna be putting this negative 3 where the x is. The negative sign is going to remain, so we're not gonna do anything with this. X squared, we're going to put negative 3. So we're going to put negative 3 in bracket. We're going to square plus x. And here we're putting negative 3 right here again. Then we minus 1. Remember, order of operation, you do whatever is in the parentheses first or whatever is in the brackets first. And here we have a negative 3 squared. What is negative 3 times negative 3?
Positive
9.
9.
Positive 9. What happens to this? What happens to this?
The negative is in front of the x, it remains.
So it remains. Very good. And then what is a positive times a negative? Positive times a negative.
Negative.
Negative. So this is a negative, and this is minus 1. What then is our result? You owe 9, you owe 3, you owe 1.
13, minus 13.
Minus 13. So it means that our answer is minus 13. The individuals who were saying 5 and negative 5, do you now have clarity on why it's negative 13 and not positive 5 or negative 5?
Sir, the
Yes.
whiteboard wasn't showing that goodness, sir. You can do a cover that process, please.
What's that?
Sir, you can show it back again, sir, because like your screen is blocking the whiteboard on my end.
All right, so let me go over again. Are you able to see the whiteboard?
No, your screen is still on the board. Like it's blocking the whiteboard.
So you're not seeing the whiteboard?
No, sir.
What are you seeing on your screen?
If f of x equals negative x
Oh,
squared.
you're seeing that. All right. The sharing is pause. Okay. You're seeing the responses, right?
Yes, sir.
All right. I don't know what is happening today. All right. Are you seeing? Oh, it's pause. It keeps pausing each time I am doing this. Okay. All right. So I need to go on new share. I don't know, new share. All right, good.
Yes, sir.
Yeah. So many technicalities today. I don't know what's happening. All right, so we have f of -3. We're going to be putting -3 right where the x is, right here. Do you see that? So we're going to put -3.
Yeah.
All right, good. What do we do with this negative sign? It comes right down here. So we're going to put it right here. Plus x, we're no longer going to put x. We're going to substitute x with -3 minus 1. All right. Remember, order of operations, you do the parentheses first. Agree?
Yes, sir.
All right. So what is -3 times -3?
Positive 9.
+9. So that goes here. We haven't used this negative sign, so it comes down, it remains in the question. A positive times a negative will give you a -3. And then you still owe -1. So in all, you're saying -9 -3 -1. Or in other words, you owe 9, you owe 3, you owe 1. How much do you owe in all?
-13.
You owe 13, so that's a -13. All right. Is that cleared up for you now? The individual
Yes,
that was
sir.
asking the question?
Yes, sir.
All right, very good. Let me go back to the presentation. All right, good. All right, here's another one. If g of x is equal to x squared minus x plus 3, what is g of -4? Remember, all you're doing is putting -4 where x is in both problems, in both aspects. Go ahead and put that in and tell me what you get for your result.
$15.
C, sir. C.
See? All right. You got somebody got 23?
Yes, sir.
All right, so somebody got 15, somebody got 23. All right, let's work that one again. What were we this was our function, right? What value were we supposed to substitute? -4? Was it -4?
Yes,
Yes,
sir.
sir.
All right, good. So remember, wherever we see x, we're gonna put that right here, and we're gonna put that right here. We're gonna put -4 in these two places. So let's write our function. So this is x squared minus x plus 3. We're no longer gonna put x, but we're gonna put -4. So this is -4 squared minus, what is x? What's our value for x?
4 minus 4.
-4. So this negative still remains -4 and then plus 3. Remember now, whenever you square a number, you multiply it by itself. So -4 times -4, what would that give us?
16.
+16. And a negative times a negative will give you
Positive.
+4
Oh,
plus 3. So 16 plus 4 plus 3.
23.
23. Good. All right. So a lot of individuals probably would have made a mistake right here, because you say, hey, there's already a negative sign. You don't have to put the -4. Remember, when you're working, please leave the signs and substitute whatever value you're given. If you're asked to substitute a -4, put the entire value and then you carry out the operation. All right. Does that answer the question? I think one
Yes.
individual had gotten that one right.
I got it right. I just didn't share my answer.
Okay. All right. So let's go again. I think we have like 2 more questions. How are we with time? So we have 1 hour on this unit, and then we're gonna have the remaining 2 hours to complete the past paper. All right, very good. We're gonna end after this one. All right. So the range of f of x, which is mapped onto x cubed for the domain -3, -2, -1, 0, 1, and 2. Remember, your domain, another word for the domain is input. These are the values you're going to put right here. What would be your range? If you cube -3, it means -3 times -3 times -3. What will be your value?
Minus 27.
Minus 27. Do we see that in the
Yes,
form
sir. Number
where
D.
we see it at
D,
D? Very
D.
good. If you cube 2, if you cube -2, what would that give you?
Minus 8.
Minus 8. So it therefore means that your answer is D. So again, the domain is what you put in. That is what we have been doing. And the range are the output, the answers that you will get. All right. Okay. All right. Good. So that's the end of this functions unit. Now we're going to be looking at past paper 2019. Are there any questions before we move on from this unit?
Is the past paper document that can be sent to email?
Yes, I think yes, it's a PDF document. I probably can share it. Do you want me to share it in the chat or what? What do we want? What are we gonna do?
Anything that's easier for you, sir.
What's that?
They could share it in the chat.
Could share it in the chat.
All right, so I'll do that. Oh, that was what portion of the screen. All right, let's see if I can get this on. No, where am I? I am at here. New share. We're still seeing that problem, right?
Yes, sir.
What are we seeing? Are we seeing the Csec paper?
Yes, sir.
Yes, sir.
All right, good. So this is what we're going to be looking at. I'm going to see, I wanted to have both screens going so that I can work concurrently, but I'm still having that difficulty. Let me see if I can still do that. Is it working?
Yes, sir.
Yes, sir. Yes, sir.
All right, finally. All right, good. All right, so now, remember now, this is what, 2019? Yes, this is 2019 last year. So a lot of times the questions, they repeat. So once you get a hold as to how to work the problems, you should be good. Again, you need to understand the structure of the examination. There are different sections: consumer arithmetic, measurement, relation functions and graph that we just did, and geometry. Those aspects, they carry the most marks. It's 8 points each, so that's 32 points already on those, on just those 4 units. Again, this is your formula sheet. If you don't remember how a formula what a formula is, you can always refer back to the formula sheet. All right. And sometimes
Sir,
when you
someone has their hand up.
all right, we can go ahead and share.
Sir,
Yes.
I noticed that there's a formula sheet on 2019. Is it possible that we'll be getting one for 2020 as well?
Yeah, you always get the formula sheet. The formula sheet is always given.
One?
What's that?
Format paper 1?
Yes, yes. Yeah. Whether it's paper 1 or paper 2, you always get the formula sheet.
Thank you.
You're welcome. All right, so let's get started now. All right, so number 1, -3 squared plus -2
Sir,
squared.
we're number 6.
You see number 6, not number 1?
Sir, number one is showing.
Number one is showing.
Yes, sir. I'm
It's on.
seeing number one.
All right, let me see if I can get that. Are we seeing number one over here?
Yes, sir.
Yes, sir. We're seeing it.
Yeah. Okay, good. All right, so -3 squared plus -2 squared, what will that be equal to? Remember, everything is coming now. We're putting everything that we have learned together. Remember, when you square a negative number, it becomes a positive. So -3 times -3, that will give you 9. And -2 times -2, that will give
Positive
you
13.
4. So what is 9 plus 4?
Positive 13.
13. So it means that our answer for number one is C.
C.
Yeah, let's look at number 2. What number, when added to 1 and 1/3, gives 2? All right, head start hurt we know. We say fraction and we head start hurt we want to move on to number 3. Guys, that's not the way we're going to do it. Remember, when in doubt, don't leave it out. Here's what we're going to do. We're going to break it up into 2 parts. You always like working with whole numbers. So we have 1 down already. And we have no 1/3.
Sir.
B.
B is the
All right, no
answer.
problem. Let's see if let me just work it for the sake of others so you can get it. Because a lot of individuals, they don't like fractions. All right, so we have 1/3. Now, if you have 1 out of 3, how many more is needed to make it up to 3 out of 3, which is a whole? You have 1 out of 3. How many more is needed? 2. So it means that 2/3. If you add 1/3 and 2/3, you're going to get 1, and 1 plus 1, that is 2. So it means that your answer here is B. All right, let's look at number 3. 11.1 divided by 0.01. What will this be equal to? Let's write that down. All right, so we have
D, sir.
11. What do we get?
D as in dog.
All right, let's confirm. 0.01. All right, so easy way. All you're going to be doing, let's look at the decimal point. All you're going to be doing is that you have to ensure that the divisor, which is this value is a whole number. And to make it a whole number, all you're going to be doing is that you can move the decimal points, or you're going to be multiplying by a factor of 10. So we're moving 1, 2. So it means that we have multiplied by 100. Moving 2 places, this now becomes what? No answer?
100.
It becomes 1. You have moved this point 1, 2, so it becomes 1. Now, because you move 2 points, you're gonna have to move 2 places on this side. 1, 2, your decimal point is here. 0 becomes a placeholder. So the number is now 1, 1, 1, 0 divided by 1. And any number you divide by 1 is simply that number. So it means that your answer is indeed D. All right, let's look at number 4. Number 4 says 12.5% of a sum of money is $40. What is the sum of money? All right, now questions like these, you see 12.5, you're saying, okay, 12.5, you're not really sure what to do. There are a number of ways to word this problem, but one way is that I want us to reason out the problem before we even attempt the question. It is always good to work with 10% and 100% and 50%. So 10% of any number is always easy. For example, let's say we're finding 10% of 50. If the number has a 0, 10% of 50 would simply be 5. You just take off a 0. If you're finding 10% of, let's say, 500, it would definitely be 50 again. So when you're working with 10%, it's very easy. All right, so let's now look back at this problem. It says 12.5 of a sum of money. We don't know how much money, but we're going to use the elimination process to help us. We're going to work with 10% before we get to the 12% because it's always easy to work with 10%. Now, if you find 10% of 45, what do you think that would be? 10% of 45. 4.5. Yes, I heard that answer. Whenever the number doesn't have a decimal point, you're moving just one place to the left. So 10% of 45 would be 4.5. What would be 10% of 320?
32.
32. And look at the result for the sum of money. It's 40. What would be 10% of 500?
50.
50. And 10% of 4,500?
450.
All right, so we got 4.5, we got 32, we got 50, and we got 450. Look at our result. It says the sum of our money, this 12.5% of a sum of money gives 40. Which of these answers is closest to 40?
32.
32. So right ahead, a lot of individuals will say 50, you know that A and you know that D are definitely out. Your answer is between B and C. And of course, 10% is not far off from 12.5%. Your answer is definitely B. There's also another way that we could work it. And let me go ahead and work that. So when you have questions closer to 10%, always go ahead and use 10%. So we said that the sum of money, you could also use the elimination process that we just did, which is 45, and 45 is out and 4,500 is out. We have eliminated those two. So we're contemplating 320 and 500. So we're saying now that 12.5% or 12.5% of 320. We need to find 12.5% of that. And whenever you have this, a lot of times students don't like to use decimals, so we can go ahead and put this into an improper fraction. What is 12.5 as an improper fraction?
25 over 2.
25 over 2.
Times 1 over 100.
25 over 2. And percentage is always out of what?
100.
Out of 100. So it's 25 over 2 over
times
100 times 320, right?
Yeah.
All right, so 25 over 2. This is what we're saying. We're saying 25 over 2. Whenever we have a line, it means that we're dividing. So it's 25 over 2 divided by 100 times 320. Do we see that so far? Have I lost anyone?
No,
This line,
sir.
This line means division. So it's 25 over 2 divided by 100 times 320. So all we're going to be doing now is simplify all of this. A simple rule. Remember now we're going to have to change our division sign to
multiplication.
Yeah, so what we simply say is you keep, change, flip. So you're keeping
25 over 2.
over 2. You're changing this to multiply, and you're flipping 100. 100 would be 1 over 100 times 320. Then now you can go ahead and simplify. This 0 can go, this 0 can go. Anything else can simplify? Yeah, you can say 2 into 32, that's 16. Have I lost anyone?
No, sir, we're getting it.
No,
Okay.
sir.
All right, good, we're good, because I didn't hear anyone. All right, so now we have 16. So now we can say 25 times 16. What's 25 times 16? 25 times 16, anybody working that?
Sir, you could simplify
Exactly, you could have 5. It is 5 into 25 and
all right, so you want to simplify. I left the 10 because remember we said that it's always easy to work with 10. So what is 25 times 16?
400.
400. And then now when you're dividing by 10, all you do is take off the 0. So it means that your answer is 40. Was that what we got here?
Yes.
Yes. So this is the second method, just working out the problem and eliminating the process. So the sum of money, which means that the money that we started with was $320. And as I said earlier on, it's easy to work with 10%. So you could also find 10%, which is not far off from 12.5, which should have also given us our 320. All right, number 5. A test was marked out of 80. A boy scores 60% of the marks on the test. How many marks did he score? So a test was marked
Yes,
out
sir.
of 80, and he got 60% of the marks. Percentages out of how much?
100.
Out of 100. So we're going to put 60 out of 100 because that's the amount that he got out of 100. He got 60 out of 100.
The answer B, sir.
And yes, and the test is marked out of 80. So 60% of 80. And again, off is another way for multiplying.
I got B.
All right, let's
Got
see
the
if we see our answer. So we can go ahead and we can simplify. That 0 can go, that can go, this can go, and this can go. 6 times 8, that is 48. So your answer is B. All right, everybody got that?
Yes,
Yes,
sir.
sir.
All right, let's look at number, where are we? Number 6. The square roots of 181, it lies between, is it 13 and 14, 45, 46, 9 and 11, or 11 and 13? When we talk about square root, what are we talking, what does that mean?
The number times itself.
Well, the number times itself is squared. So the square
And
root
it
will be
is
the opposite of that. So if we say the square root, what would be the square root of 100?
10.
10.
10, because 10 times 10 is 100. So we need to find what two numbers will lie between 100 and 81. Let's look at the answers. 13. When you multiply 13 by itself, what would you get? What's 13?
169.
169.
Very good. And 14 times 14.
196.
196. All right. Let's look at the problem now. The square root of 181, does it lie between 13 and 14? Look at the answer for 13 and 14. That's
Yes, sir.
Yes, sir.
169 and 196. Let's look at B, 45 and 46. That is already out. 9 times 9, that's 81. And 11 times 11 is 121. That is already out. So your answer is what?
A.
A. Your answer is A. So the square root of 181, it lies between 13 and 14. Very good. Number 7. Which of the following set is defined by X is an element of Z? What does Z represent? Anybody knows what Z represents? The symbol Z? Not sure?
Real number?
No, integers.
Integers.
Yeah, so Z represents integers. So don't be confused with these symbols. So X is an element of the set of integers where X lies between -2 and +4. Guys, remember we said this symbol. What does this symbol means?
Less than or equal to.
Less than or equal to. So should the value be included? Should the
Yes,
value
sir.
be included?
Yes,
Yes,
sir.
these two values must be included. So what this is saying is that we're going to start at -2, which is also included. We need all the numbers ranging from -2 straight up to +4. And -2 and +4 must be included. So after -2, we have -1, then we have 0, then we have 1, then 2, then 3, then 4. These are all the numbers that satisfies this. So what would be our answer?
D.
Our answer would be D. Very good. Number 8. If Q is equal to a set where you have A, B, C, how many subsets can be obtained from set Q?
D.
D, sir.
4 to the
Plus
3.
C. Which one?
D as in dog.
D as in dog, 2 to the third
D.
power. Remember now, the formula for finding subset is always
2 raised to the amount of number.
yes, raised to the amount of number in that set. So this set has how many elements?
3.
3 elements. So we're going to substitute n with 3, the number of elements. So it will be 2 to the third power. So n represents the number of elements that is in the particular set. All right. So your answer is indeed D. All right. Number 9. Item 9 refers to the following diagram. So this is the only question that comes from this diagram. In the Venn diagram, the number in P is 5, and the number of elements in Q is 9. And the number of elements in P union Q, meaning that when both are combined, you get 10. What is the number of elements in P intersect Q? Remember now, the intersection represents this section right here in the middle. We need to find out how many numbers would be there. All right, there are two ways that you can work it. All right, so there are two ways to work them. So the number of elements in P, that's 5. And the number of elements in Q, that's 9. Now, when you combine that, combination will be 9 plus 5, you get what? 14, right? Do we agree?
Yes, sir.
All right, good. And then now it says the number of elements in P union Q, that is 10. P union Q is 10.
14 minus 10 equals.
So it means that we need to do some form of operation, which is subtraction. We need to subtract because the number of elements in the union must be 10 and not 14. So we need to subtract 10 from 14, we're left with 4. This 4, what does it represent?
Intersection.
The intersection. So it means that the number of elements here would be 4. Do we get that?
Yes, sir.
All right, good. And there are some visual learners. For the visual learners who like to see things, you can also do that. So if there are 4 elements here, 1, 2, 3, 4, and there should be 5 elements in P, it means that 1 element will be here. And there should be 9 elements in Q. 4 is already here, so it means that 5 will be here. If you should add all of this, you should get 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is for the visual learners who likes to see things. So you can clearly see that there are 4 elements on the inside. Let's go now to number 10. So you should have about how many set problem? 3 or so. All right, so this is your final set problem. No, you have 2 more, sorry. All right, let's look at number 10. Item 10 refers to the following information. P is equal to a set of prime numbers. Q is equal to a set of odd numbers, and R is equal to a set of even numbers. Do you remember what these types of numbers are? Do you remember what are prime numbers?
Yes, sir.
Yes, sir.
What are prime numbers? Anybody remembers what are prime numbers? Anybody wants to share prime numbers? No? All right, so prime numbers, they have 2 factors, 1 and itself and the number itself. Odd numbers, what about odd numbers? Anybody sharing odd number?
Cannot be divided.
Any number that
Cannot be
is
divided
divisible
by.
by 2 and leaves a remainder.
Yes, and even numbers, what are even numbers?
Can be divided by 2 though.
Good, it's divisible by 2. All right, so let's look at the question now. Which of the following set would be empty, meaning that there is no relationship between them? If
Q
you
and
have
R.
Q and R, all right, let's look. You said B, which is Q intersect R. Let's look. Q is odd numbers and even numbers. Will there be a relationship between odd numbers and even numbers?
No.
No, sir.
No, there will never be.
No,
There
sir.
will never be. So it means that that would be an empty set. So your answer would definitely be B. Let's look at 11. If P equals 2, 3, 5, 7, and Q equals 2, 3, 6, and S equals 2, 4, 5, then P intersect Q intersect S. Remember now, the intersection refers to what is common. What value or values do we see that is common to P, Q, and S?
2.
2.
2. So it therefore means that your answer is what?
A.
A.
A. All right, good, very good. All right, item 12 refers to the following Venn diagram. Let's look at the Venn diagram. These lines that you see there, it's just making reference to it being shaded. So think of it of being shaded, all right?
Complement.
P complement. What a big word. What does that mean? What does a complement means?
Everything except in.
Yes. So the complement means everything outside of. So let's look at it carefully. P, there is no part of P that is shaded. So we will call that P complement because it's everything that is shaded outside of P. So yes, your answer is indeed A, which is P complement. Are there any questions on this before we move on? Because I think this is all your sets now. You're now
Sir,
going to be going,
can you explain the other options, please?
what are the options?
B, C, and D.
Oh, P union Q. P union Q means P and Q combine, and the complement would be outside of. So it means that only the outside would have been shaded. Q intersect P complement. P complement, which is being represented here, and Q. So it would be everything. And Q would be shaded right on here. And then the final one, Q intersect P complement. Q intersect, remember the intersection means what is common. So everything would have been shaded and including here. This is the part here would also be shaded, but it's not shaded. So it cannot be B, C, or D, but it's rather P complement because P complement refers to everything outside of this given set. All right, so now we're going to be looking at consumer arithmetic. Consumer arithmetic is a big deal. It's like 8 points, so we have to see if we can maximize on this. All right, so if TNT $6 is equivalent to US $1, then TNT $15 would be how many US dollars? All right. Guys, don't be frustrated. All we're going to be doing, we're going to be reasoning out this problem. We're not going to be doing any big kind of maths. All we're going to be doing is just that we're going to be reasoning this. So TNT $6 is equal to $1 US. And if you have TNT $15, in other words, it's asking how many US dollars would you have? Now, let's reason it out together. We're not going to work out a whole lot. All we're going to be doing is reasoning together. Now, if you have 6 TNT dollars, and that gives you $1, right? Now you have 15 TNT dollars. If you take 6 more of it, how many US dollar can you get? So 6 gives you 1 US. And if you take 6 more, how many US can you get?
2.
6 will give you another 1, right? So 6 plus 6, that's 12. How many TNT dollars is left?
3.
3 is left, right?
3.
Yeah.
So we have 3 left. Now, if 6 TNT dollars give you 1 US dollars, how much would 3 TNT dollars give you in US?
50 cents.
Very good, 50 cents. And all you do, you add them now. 1 plus 1 plus 50 cents will give you what?
2.50. 2.50.
$2.50. So you see, you didn't even do a whole lot of working out. All you did was reason it out. Because if you have 15 TNT dollars, you break that up because 6 gives you 1. You get another 6, that's 2. You're left with 3, which is indeed half of 6. And half of $1 would be 50 cents. So it's $2.50. All right, let's go to any question on number 13?
No, sir.
No? There's always another way if you want to work it the algebraic way, no problem. 6 TNT dollars gives you $1. 15 TNT dollars gives you how much? You don't know. You can do this by using proportion ratio. 6 times x gives you 6x. 15 times 1 gives you 15. You divide both sides by 6. 6 divided by 15 will again give you 250. So you have 2 ways to work it. You can reason it out or you can work it out. It doesn't matter. Both ways will give you the same result. All right. Number 14. If $7,000 is borrowed at a rate of 5% per annum for 3 years, the simple interest is, do you remember the simple interest formula? Do you remember the simple interest formula?
PRT over 100.
Good. Simple interest is PRT over 100. And we have all that information there. Once we have all that information, all we're going to be doing is substituting. Our principal is 7,000. Our rate, 5. And our years, 3 years. And it's all over 100. These two can go. 70 times 5 times 3, so 70 times 15, that will now give us 1,050. Do we agree? What does this say?
Yes, sir.
All right,
Yes,
good.
sir.
All right, good.
Correct,
So,
sir.
yes, so your answer is D. Let's go to number 15. A dress which cost $180 is being sold at a discount of 10%. So remember, guys, I told you from the beginning, it's always easy to work with 10%. So we don't even have to do a whole lot with this question. A dress which costs $180 is being sold at a discount of 10%. The amount of the discount is, remember when we are working with 10% and the number has a 0, all we do is take off that 0. So 10% of 180 means that you're taking off the 0, you're going to be left with $18. So the amount of the discount is how much?
$18.
$18, just like that. So again, when you're working with 10%, if the number has a 0, all you do is take it off and you are good. So your answer here is C. All right, number 16. The value of a plot of land is 18,000. All right, so let me write that down. And land tax is charged at a rate of 0.7. So that's the rate per 100 value. So for every 100 value, you are charged a tax of 70 cents. What is the total amount of tax that is paid on the land? It looks a bit wordy, but let's reason it out. All right. So first of all, you had 18,000, right? Everybody agree? You had 18,000?
Right.
All right, good. Now, it says that the land tax is charged at a rate of 70 cents per 100. Now, if you started with 18,000, right? How many hundreds can you get out of 18,000?
180. 180.
Good, that's 180. And an easy way, again, it's always easy to work with 10, 50, and 100. So this will go, this will go. So you have 180. Are you done yet? You're not done. What is the rate? At what rate are you charged?
0.7.
0.7. 0.7 or 70 cents, yes. So no, it means that you can get $180 out of the 18,000, but you need to be charged, you're going to be charged at a rate of 0.7. So it means that you're going to have to be doing 180 times 0.7. Do we agree? It cannot be added. You're charged per 100. So every 100, it's going to be increasing. It's going to be increasing, and it's being multiplied. So it's now 180 times 0.7, 7 times 0, 7, 76, 12, 0, 0, 0, 0. All right, what's our answer? That's 126. Do we agree that our answer is 126?
Yes, sir.
Yes, sir.
Good. So again, let's reason this question. You have 126. Yes, 126. Good. I hope you're not using calculators, Hope I can trust you not to use a calculator, because we won't be using a calculator for the examination. All right, so you have 18,000. How many hundreds can you get out of that? 180. You are charged 70 cents per 100 value. So all you do is multiply 180 times 0.7 and you get $126. All right. We're coming down with the consumer questions. You have like 5 more. All right, number 17. At the end of any year, a at the end of any year, a car is worth 5% less than what it was worth at the beginning of the year. If a car was worth 9,500 in December 2016, then its value in January 2016 was, let's work it out. So you have only two numbers you're given here, very simple, 5%, and you have 9,500. All right. So initially what the question is asking is, which of these value was the value of the car before it decreased by 5% in order for you to get 9,500, all right? So let's go. All right, so the first option, you have 9,995, you have 10,000, then you have all those values. All right, anybody have any answer before we move on, before we get into how it's worked?
A, sir.
A, 9,995. Somebody else says A as well?
Yes, sir.
All right, let's find out what our answer is, if it is indeed A or not. So a lot of individuals says A. We're going to test it. So all we're going to be doing trial and error. We're going to be selecting answers.
I got B, sir.
You got B? Okay. We're going to be finding 5% of A and B. And if anybody has got the other answers, we're going to find 5% of these numbers. And we should get 9,500. All right. Now, there's always two ways to work the problem. So we're going to work with one over this side and the second way over this side. All right. So we want to find out what the value of the car was. So somebody says 9,995. So we need to find 5% of that. So 5 over 100 times 9,995. All right. All right. So what we can now do, remember, once you're working with 100, it is always good to multiply across and then you divide by 100. So we're going to be doing 5 times 9,995. Can somebody go ahead and do that? Or do I need to do that as well? So you're doing this. You're doing 9,995 times 5. What's our result? Can someone go ahead and do that? 9,995 times 5. What do you get? Nobody doing it? Anybody?
49,975.
49,975.
75.
Yeah, that's right. All right, good. So 5 times 9,995. Now we're dividing by 100, so we're moving 2 places. That's 1, 2. Dividing by 100 will give you 499.75. Now we're going to be subtracting. We're going to be doing 995 minus 499.75. That's 4, that's 0, that's 5, and that's 9. Was this what the car was worth? Is it 9,504 or is it just 9,500? It's just 9,500. So it means that A is not your answer because
That is not the answer.
yeah, when you find 5% of 9,500, it does not give you back your when you find 5% of 9,995, it does not give you 9,500. Let's test 10,000. We're gonna find 5% of 10,000. So it's always easy now. 10,000 is easy to work with. So that can go, that can go, that can go, that can go. So now we're doing 5 times 100, which is 500. Then we're doing 10,000 minus 500. What's 10,000 minus 500? 10,000 minus 500?
9,500.
9,500, which we have here. So what will be our answer?
B.
Our answer will be B. All right. There's also another way that we could have worked to get B as our answer. 5% less. If you get remember now, percentage is out of 100, right? And if you get 5% off, how much are you actually paying for? How many percentage is left? If you get 5% off.
95.
95. So that's also another way you could look at it. You could also say 95 over 100 times the 10,000. And then you could cancel this times this.
9,500.
9,500. Good. So either way you work it, you still get 9,500. First, method one, you could find 5%. Whenever you get that value, you subtract it from the original number, or you could less the 5% from 100, which would give you 95%, so you don't have to subtract again, which would be 9,500. All right. So your answer here is B. Let's look at number 18. A loan of $8,000 was repaid in 24 equal monthly installments of 400. The rate of the interest on the loan was all right. Let's write the information that we have. The loan was $8,000, so that was the loan. Monthly installment, 24 monthly installment. Monthly installment of 400, right? All right, so let's reason the problem again. For 24 months, every month you have to pay $400. How do you find out how much you would have paid in that time period? 24 months, and every month you have to pay $400. What would we have to do to find out the amount that you pay overall?
Times 400.
400 times 24.
24.
Right? Anybody wants to do that? What do we get?
A, sir. A.
Wait. We're doing 400 times 24 first. We're not getting to the answers yet. Anybody?
9,600.
Is that all right? So 400 times 24, that's 9,600. So it means that over 24 months, you would have paid 9,600. How much was the loan?
8,000.
The loan was 8,000. So how much did you overpay? How much did you overpay? So you're taking out, it's like something like hire purchase. You take it out and then you're actually paying more. So you're paying 1,600 more, right?
Yes, sir.
All right, good. So we agree that you're paying 1,600 more. What was the original loan? What was the original loan?
8,000.
Original loan was 8,000, good. Times 100. All right, so all we can do now, we can go ahead and simplify. So we can take 1, 2, 1, 2. We can also take here. 8 into 8, 1, 8 into 16, 2. What's 2 times 10?
20.
20. So it means that the rate of the loan was D, which was 20%. Any questions for that? Do we see how we got our result?
Yes, sir.
The individual that said A, that wasn't correct. All right. So for 24 months, you're paying $400. So 24 times 400, that is 9,600. And the original loan was 8,000. So you subtract 8,000 from 9,600.
Check out that. Are you ambitious? But she can add them up to me.
Guys, can we mute your microphones? So again, you're paying over 24 months, you're paying 400. So that's 400 times 24, which will give you 9,600. The original loan was 8,000. So you're overpaying 1,600. 1,600 of 8,000 will give you 20. So your answer is D. All right, let's go now to number 19. Yes.
Is
Question?
easier alternative to work that question?
What in this alternative didn't you understand? Is there something in this one you didn't understand?
No, I just wanted to know if there was an easier alternative.
Yeah, but I didn't want to go into that alternative, because I think sometimes when we get into the larger numbers, a lot of individuals get confused. So I tried to choose the simplest one here. All right, number 19, a dinner at a restaurant was advertised at $60 plus 18% tax. The total bill for the dinner was, so you go on a dinner, you go at a restaurant for dinner, and it costs $60, and you have a tax of 18%. Remember now, tax means you're paying more. So it definitely means that A is already out because you're paying more. So your answer is between C, B, C, and D. All right. So $60 was the total and 18% tax. So we need to find 18% of 60. So 18 over 100 times 60. Take that off, take that off. You can do 18 times 6. 6, 8, 48. That's 108. Then you divide by 10. So that would be 10.8. So the tax is 10.8. And the cost of the dinner is 60.
Yeah,
so your answer would be?
B.
B, yes. B as in boy. So it's 60 plus 10.8, which is 70.8. Another way you could also work it, remember tax means you're paying more, and percentage is out of how many?
100.
100. So if you're paying more, what you're actually paying is 118%, because tax is more. That is out of 100 times 60. This can take this, and then you can do 118 times 6, and you divide by 10, and then that will give you your total of 70.8. So either way you work it, whether you want to find 18% first, and then you add that to the price, or if you want to find the overall thing together. So there are always two ways or more to work the problem, but you can always choose a simpler way. All right, I think this is our final consumer question, number 20. At a sale, each book was marked $3 off the original price.
So easy.
At a sale, each book was marked $3 off the original price. Daniel paid $46 for 2 books at the end of each sale price. What was the original cost of 1 book? Now, if he bought 2 books, how much would he have gotten off? If you get $3 off 1 book and he bought 2 books, how many would he have gotten off?
$6.
$6, good. So he originally paid 46, and 46 plus 6. What he should have actually paid was what? 46 plus 6. He should have actually paid $52. Now, if he bought 2 books and they cost the same, it means we're doing 52 divided by 2, which would give us what?
46.
Check again. We're dividing
26.
By 26.
6. Mistake.
Yeah, simple mistake. All right, so your answer here would be D, which is 26. Any questions?
No, sir.
All right, good. All right, so we're getting there now. All right, now we move on to algebra, which is also a big thing. This is also 8 points again. All right, 21. 1 over 5x plus 2 over 3x. 1 over 5x plus 2 over 3x. What is our LCM? What is our lowest common multiple?
15.
15x.
All right, good. There's
15x.
so it's 15x. That is our LCM. 5x into 15x. That's
3.
3.
3.
3x to 15. 3x into 15. Into 15x.
5
5.
times 13 over 15.
So your answer would be 13 over 15x. So your answer is D. And guys, don't be mistaken. Look at these two. They're extremely close. A lot of individuals will probably choose C, but C, 15x squared is not a factor because x squared wasn't a factor right here. The factor that was there was x, so you cannot use x squared. All right. All right. Let's now move on to number 22. When 5 is added to a certain number, and the result is multiplied by 3. The final answer is 27. What is the original number? All right. When in doubt, we're going to work it out. All right. So 5 is added to a certain number. We don't know what the number is. So 5 is added to a certain number. We can use x for that number. So 5 is added to x. Now, when you add 5 and x, that result is multiplied by 3. All of this, when you add it, what should it be multiplied by?
3.
By 3. All of this is multiplied by 3. And then your result, what is your result?
27.
27. So all we have done, we have made a simple equation. Now we're going to solve. Remember, parentheses or brackets means we multiplied. We multiply 3 times 5, that's 15. 3 times x, that's 3x, equals 27. Now, we need to find out what x is. We need to subtract 15 from both sides. That's gone. We're left with our 3x, so that goes down. What is 27 minus 15?
12.
12. We need to find out what x is, so it therefore means
4.
we need to divide both sides by 3. Very good. So x is
4.
4. Ah, good. If you're sure about your answer, you can go ahead and try it. 5 is added to a certain number. Now we know what the number is. 5 is added to 4. What's 5 plus 4?
9.
9. Now that 9 is multiplied by 3. What's 9 times 3?
27.
27, which was what you got, right?
Yes, sir.
Good. So that's the beauty of it. You can always check your answer and you can be confident about your answer. So your answer is definitely, without a doubt, 4. All right, number 23. What is the value of x squared plus 3y over xy if x is equal to 4 and y is equal to 2? All we're doing here is we are substituting. Wherever we see x, we're going to put 4. Wherever we see y, we're going to put 2. So we have x squared plus 3y over xy. We know that x is 4 and y is 2. All right. So we're going to substitute right here. We have x squared. We're now going to say 4 squared plus 3y. 3y means 3 times y. And now we know that y is 2. So it's 3 times 2 over xy. Xy means x times y. So it's 4 times 2.
Answer B.
B? All right, let's not be quick. Let's work it out. What's 4 squared?
16.
16 plus 3 times 2, that's 6, over 4 times 2, 8. What's 16 plus 6?
22.
22
So
over 8.
22
divided by 8.
But you're saying, no man, the answer is not there. And you say, geez, the answer is not there. What do I have to do? But don't worry. This can be changed into it can be changed into a mixed number. It can be changed into a mixed number. So 22 over 8. How many times can 8 go into 22?
2 times.
2 times. 8 times 2, that's 16. How much more is needed to make it to 22?
6.
6 over
And then
8.
you work that out again and you say, but wait, the answer is not there.
3/4.
Break it down.
But it can be reduced. So what's your final answer?
2 and 3 over 4.
2 3/4. So your answer is D. All right. All right. 24. If x is an integer that satisfies the inequality 4 less than 2x less than or equal to 6, then what do we do? All right, guys, don't worry. This is fairly easy. All we're doing, all the question is asking you is to simplify and find what x is. All right, so if we look, x is on the inside and this is saying 2 times x. What's the opposite of multiplying a number?
Divide.
Divide. So it means that everything, all 3 values will be divided by the number that is in front of x. So we're dividing by 2, we're dividing by 2, we're dividing by 2. Does everyone saw why I divided by 2?
Yes, sir.
Good, we divide by, no? We have x here. What number is in front of x? That is what it says. If x is an integer, or we are concerned about the x, but there's a 2 in front of the x. So that is why we divide by 2. If there were a 3 in front of the x, we would have divided by 3. So we divide by 2. 4 divided by 2, that's 2. The sign comes down. This goes, you're left with x. 2 into 6, that's 3. So what's your answer?
A.
Our answer is A. Good. So all we did was that we divided all the terms by +2 and we would have gotten A. All right. Sorry about that. 20, where are we now? 25. All right. Let's go with 25. 25 says the sum of 2 positive numbers, P and Q. If you add P and if you add Q, you get 32, right? But their difference, what does difference mean? What does difference mean?
Subtract.
Take away.
Subtract. But when you subtract them, which is P minus Q, you get what? 12. Anybody knows what this is? We have a pair of equation. What is it called? I hear it.
Simultaneous equation.
So we end up now with a pair of simultaneous equations. So we have P plus Q, which is 32, and P minus Q, which is 12. All right. The question asks us, what is the smaller number? So we're gonna have to find out what P is and what Q is and find out which one is the smaller number. All right, so a pair of simultaneous equation. P and Q are already the same. So in order to eliminate, we can use the elimination process. In order to eliminate, we can go ahead and subtract. We subtract because if you added P plus P, you would have gotten 2P. That does not eliminate it. We subtract because P minus P will eliminate that process. Do we see that? Do we see that?
Yes, sir.
All right, good. So P minus P, that eliminated the process. Not eliminate for P. Now we're going to be doing Q minus negative Q. What is Q minus negative 2? Whenever you have 2 negative, what happens to it?
Yeah, add.
Positive.
You add. So what is Q plus Q? In other words, you're saying Q plus Q. You have 2 Qs, right?
Q squared.
So we have 1 Q. I have another Q. How many Qs do you have?
2Q.
2Q, yes. So it's not Q squared, it's 2Q. All right, next part. 32 minus 12. What's 32 minus 12?
20.
20. Good. Now we have 2Q equals 20. It therefore means you're going to be dividing both sides by 2. So it means
10.
that Q is 10. But we don't know if Q is the smaller number or the larger number. Let's check. We can go ahead and substitute. We can choose any one of the equations. We can say P plus Q equals 32. We know that Q is 10. We have 32. what we can now do, we can subtract 10 from both sides. If you
12.
take 10 from 30, if you take 10 from 32, you're left with
12.
what? Check again. You have 32 and you take 10.
22.
Yes.
22.
Which one is the smaller number? Is it 22 or is it 10?
10.
10. So your answer here is 10. And of course, you can check your answer. If you add 10 plus 22, you indeed get 32. And if you have 22 minus 10, you get 12. So it means that your answer is indeed correct. Let's move on to 26. 26 says 3x squared times 2x to the third power.
6x to the fifth power.
6x to the fifth power. Do we agree?
Yes.
All right. 3 times 2, that is 6. The laws of indices states that when the bases are the same and the bases are the same
You add
here,
the exponents.
you add the exponents, and 3 plus 2 is 5. So your answer is 4. All right, good. All right, number 27. So now we're moving on to vectors and matrices, which I think you will get more problems. All right, vectors and matrices now. Number 27. Two matrices, A and B, they are conformable by multiplication A and B if conformable, it means that they are compatible. Now, in order to decipher if two matrices are compatible, we can do something to find that out. Very easy, and then we can get to this. Remember, when we have matrix, it's always row times column. Do we agree?
Yeah.
Do we agree?
column.
Yes, it's always row times column. Now, we can know that two matrices are compatible if, let's say we have a 2 by 3 matrix and we want to multiply, let me not put the bracket there to confuse you. And let's say we have a 3 by 3 matrix. You have a 2 by 2 matrix and you have a 3 by 3 matrix. Row times column. So this is our row and this is
2
our
times
column.
3.
This is our row and this is our column. Let me just show you something now. You know that two matrices are compatible or conformable if these two numbers on the inside, if they are the same. If these two numbers are the same on the inside, it means that it can work. It can be multiplied. So let's now go to the problem. Two matrices A and B are conformable for multiplication A times B if the number of rows in A is equal to the number of columns in B. Is that correct? Is that correct? Is A correct?
Yes.
No, sir.
No, B is the answer.
No, sir.
No, A is not correct. Because these two are not equal and they are conformable. So A is not right. Let's look at B. The number of columns in A is equal to the number of rows in B. All right, let's look at this. Remember, it's row times column. This is the column on the inside, and it's row times column, the row on the outside. So it's the number of columns. This is the number of columns, which is 3, and the number of row is also 3. Once they are the same, it is conformable. So your answer would be what?
B.
B, your answer would be B. So yes. So this is all that is saying. Once you understand this concept, it's always row times column. So two matrices are conformable if the number of column in the first is equal to the number of row in the second problem. That's all that is saying. All right, number 28. The determinant of the identity matrix. Look at the note here. All right, the identity matrix. The identity matrix is this matrix, 1, 0, 0, 1. Have you ever seen that matrix before?
Yes.
Yes.
All right, good. This is what is called the identity. This is what is called the identity matrix. No, the determinant. The determinant is always the leading diagonal, which is here, times the non-leading diagonal. So what is 1 times 1?
1.
1 minus what? 0 times 0.
0.
0.
So what is 1 minus 0?
1.
1. So the determinant of the identity matrix is what?
1.
1. Good. And your answer there would be A. Remember now, determinant is the leading diagonal, which is this one, times the non-leading diagonal. 1 times 1 is 1. 0 times 0, 0. You subtract and you get 1. All right. Number 29, almost halfway through. All right. If the vectors P and Q are 3, 2, and negative 1, 4, respectively, we're asked to find P minus 2Q. And remember now, 2Q means 2 times Q. P is 3, 2, and Q is negative 1, 4. We want P minus 2Q. We know P is 3, 2 already. 2Q means 2 times Q. This is our value for Q. Do we agree?
Yes, sir.
Yeah.
All right, 2Q now means you're multiplying.
Q 2 times.
Yes, or you're multiplying this 2 by each element. So 2 times negative 2 times negative 1, that's negative 2.
Negative 2.
And 2 times 4, that's 8. All right, so now that we know that 2Q is this, we're going to subtract. What is 3 minus negative 2?
5.
That's 5. And what is 2 minus 8?
Negative 6.
Negative 6. So what's your answer?
D.
D.
5 negative 6.
Yes, your answer is D, which is 5 negative 6. Yes, your answer is indeed. So guys, they realize it's not that difficult. You just need to understand what 2Q means. And 2Q means 2 times Q. So it's 2 times negative 1 and 4. And then you subtract. All right, final vectors question. Item 30 refers to the following parallelogram. WXYZ. In the parallelogram, XY, this is our arrow showing the direction, the velocity, the direction. So XY, here is X and here is Y. This is equal to, sorry, X and Y, this is equal to U. And X and W, here's X and here's W, that's equal to V. Do we see the diagram clearly?
Yeah.
Do we see the diagram?
Yes,
and
sir.
And now it says R is the midpoint of YZ. Here is Y and Z. R is the midpoint. The question now asks us, what is WR, which is here to here, expressed in terms of U and V? So let me just do a little diagram right there, where you can see. So in other words, we want to find out here. Do we agree? So now we have like a little triangle. Do you see that?
Yeah.
All right, good. So let's assess the problem. So what do you know about the sides of a parallelogram? If this side is U, what do you think this side will be as well?
U.
This side will also be U. If this side is V, what do you think this side from Y to Z, what do you think it will be?
V.
Negative V.
Also be V. Good, they're equal, so parallelogram. All right, so now that we have established that, let's look at the direction. This is going this direction. We now need to find what WR is. We need to find from W to R. So it therefore means we need to find this result. The resultant vector means we're going to be adding this and this. All right, so we need to add U to Z, and from U to Z, that is U, right? Because these two are equal. Now, YZ, this was V, but R is the midpoint, and midpoint means halfway. So it will be half of V. Do we agree?
Yeah.
We agree that it's half of V, right? No, remember now, this is now, let's look on this side. This arrow was going downwards, and this was V. It was a positive V. this arrow is going in the opposite direction. Will it still be a positive?
No.
No, it will now be a negative. And remember, R is the midpoint, which means halfway. So it will be half of V. What now is our answer?
A. U minus half
Is-
V.
Yes, so our answer is definitely A. So let me run that through again. This is a parallelogram. The question clearly told you that it's a parallelogram. There is equality. So this is U. This side will also be U. This side is V. This side will also be V. The question then went on to say that R is the midpoint. Midpoint means halfway through. So this is half of V. However, this arrow was going downwards and this arrow is now going upwards. So it will no longer be a positive V, it will now be a negative. So that's why we end up with U minus half V. Is that clear? We're halfway through the paper. Is that clear?
Yes, sir.
All right, good, very good. All right, let's now move on to the other half of the paper. Where are we? All right, so now we're at 31. All right, 31, now we're getting into measurement. Measurement is, again, a big deal. It's 8 points. We have to get the 8 points. You can't leave out any. All right, so given that 1 millimeter is equal to 1 over 1,000 meters. 2,500 millimeters in meters would be what? All right, so of course, there are two ways to work it. Both ways are very simple, so I'll show you both ways. The first way is, of course, doing the algebraic way. 1 millimeter, you're given, the question told you that 1 millimeter is equal to 1 over 1,000. And the question asks you to find 2,500 millimeters into meters. We don't know what that is, so I use X to represent that. Do we see these two equations? Do we see them, guys?
Yes, sir.
All right, so what we can now do is that we can cross multiply. We can multiply X times 1, which will give us X, or if you want to say 1X, that is fine. A lot of times students do that. And then we're doing 2,500 times 1 over 1,000. So 1 over 1,000 times 2,500. These two zeros can go. We're left with 25 divided by 10. Remember, it's always easy to divide by 10. There's no zero, but we can move one place. So your answer would be 2.5. Do we agree?
Yes, sir.
All right,
Yes,
so this
sir.
is good. So this is one method. There's also another way that we can simply use this acronym that you normally do, that you normally use in school. I don't know if you guys use it. Kick him down, Mr. Don't commit murder, something like that. Just to remember,
Yes.
units. Yes. So kick him down, Mr. Don't commit. All right. All right, so here's what we're going to be doing. The question asks us, we're converting from millimeters to meter. So this is our unit meter, and this will be our millimeters. Do we agree that this is meter and this is millimeter?
Yes, sir.
All right, good. We can now go ahead and write our 2,500. We're going to use each value to take up the places. So this is 2,500. Do you see the two lining up with the meters? Because that's what we're talking about. This is 2,500 meters, right? Do we get that? All right, now we're moving from millimeters, which is right here. We're moving from millimeters to meters. So we're going to move 1, 2, 3. So your answer is 2.5. So either way you work it, whether you want to work the algebraic way, or if you want to just do this and move the amount of units, you get 2.5. Any questions? Any questions?
No, sir.
No,
All right,
sir.
no, so we got both ways. We got both ways. All right.
Yes, sir.
All right, good. Let's move on to 32. Item 32 refers to the following diagram, which shows a sector of a circle. And of course, you know, an entire circle, it measures, it has a revolution of 360 degrees. it is such that AOB, remember when we did angles in our previous presentation, we said that the letter that is in the middle, that is the letter, that is the angle in question. So O is 60, as we can clearly see here, and OB is R units long. We need to find the area of this sector. Remember, we got the formula. If you are ever in doubt, you can go back to the formula sheet, but I need you to understand the concept. Now think about the total revolution as a pizza, right? Now you have a pizza, and you're taking one slice of the pizza. The entire pizza, how much did it measure in a revolution? How much did it measure?
360 degrees.
360. One slice, you take one slice. How much degrees does that one slice measure?
60 degrees.
So you take 60, yes, out of 360. So the area of a circle now is pi r squared, so we're multiplying times pi. We're multiplying by pi times this unit. What did the question told us? How many units is it? We don't know. We have to be using the letter. So this is r. So this is pi r squared. You're multiplying 2 times r squared. All right. Can we reduce anything here?
Yes, 6 over 360.
Yeah.
6 over 360.
1 and 60 into 360.
6 times.
6. So your answer is 1/6 pi r squared. What's our answer?
A.
Our answer is A. All right, good. So you see how simple it is, even without going back to the formula sheet. You just understand the concept that this is like taking out a slice of a total revolution times the area of the circle. All right, let's look at 33. 33 would have done volume in the previous class last week. The volume in cubic centimeters of a cube of edge 3 centimeters. The volume of a cube is length times length times length. And we have the length of one edge to be 3, so it's 3 times 3 times 3, which is
27.
27, yes, so your answer is C. All right, let's now move on to 34. 34 says the area of a square is 48 centimeters. Sorry, the perimeter of a square is 48 centimeters. What is the area? What do we know about a square?
24.
4 sides.
4 sides.
The four sides are equal, right?
Yeah.
The perimeter of that square is 48. If all all 4 sides measure the same, to find one side, we can simply divide by 4, right?
Yeah.
Yes,
all right, so
sir.
one side would be what?
12 centimeters.
12 centimeters.
All right, good. Because if you add all these, you get 48 now, right? Now, if the perimeter is 48 and one side measures 12, how do we find the area of a square?
Length times
Length
times width. So we want to find out here. So it will be 12 times 12, which will be what?
144.
144. So your answer is D. All right, good. All right, 35. Which of the following figures, not drawn to scale, so they're not drawn to scale, has an area equal to 1/2 5 plus 4 times 2. Now, if you look at the diagram, you might be confused and saying, whoa, I don't know what to do. But what type of diagram is represented here? What's the name of this diagram?
Trapezium.
Trapezium, good. You can always go back to the formula sheet. It was given. Where is it? All right, so you can always go back to the formula sheet. Where is trapezium? Here it is. So area for trapezium, the area for trapezium is A equals 1/2 A plus B times H, where A and B are the lengths of the parallel sides, and H is the distance between the parallel lines. So let's now go back to our question. So again, parallelogram is 1/2 A plus B times H, where A and B are the parallel lines. So let's see which one that is. Hold on. All right, almost. Where am I? Which number are we? Okay, good. All right, so let's look at the problem now. These are the pair of parallel lines, and it says 1/2 5 plus 4. So this would be 3 plus 4. So it means that this is wrong, right? Let's look at B. 4 and 5, yes, but let's look at the height. Is the height 3/2? The height is not 3/2. The height is 2. So we're looking for a height of 2. So B is also wrong. Let's look at D. These are our parallel lines. So it's 1/2 4 plus 5 or 5 plus 4 times our height. And you can clearly see that the height here is 2. So it means that our answer here is what?
D.
D. All right, good. 36, I think this is the last measurement question. The area of a rectangle is 53.6. How do we find the area of a rectangle? Anybody? How do we find the area of a rectangle?
Half base times height.
Rectangle.
Oh,
Length times width.
length times width.
Length times width. So the area of a rectangle is 53.6. It says if the length is multiplied by 4, so this was the length, it's going to be multiplied by 4. So we're saying 4 times L. And the width is half. So you're finding half of the width. Half of the width. We need to find out what would the area be. So remember, length times width. We don't know what the length or the width was in the original problem, but we do know that the original, the area of the rectangle was 53.6. We can go ahead and multiply the numbers. What is 4 times a half? Or in other words, what is a half of 4?
2.
2. So we have 2 times the length and the width. We don't know what the length and the width was, but we do know that the area is 53.6. Do we agree?
Yes, sir.
All right, so what we can now do, look what length times width. Look, length times width is equal to what?
The area.
Which is what?
53.6.
Ah, good. What do you have here? You also have length times width, right?
Okay, divide by 2.
Hold on now. What is length times width?
The area, which is 53.6.
Good. Right here we have length times width, which should be what? 53.6. So we're doing 2 times 53.6. Not divide, but multiply. 2 times 53.6, what would be your answer?
107.2.
107.2. All right, good. Do we get that one? We got that?
Yes, sir.
All right, good. So again,
Yes,
area
sir.
of length times width is 53.6. It says the length is times 4 and the width is half. A half of 4 is 2. Length times width. The original problem says the length times width was 53.6. So all we did was to replace that. 2 times 53.6 is 107.2. All right. Oh, we have 2 more. Yeah, we have 2 more measurements. Oh, yeah, it was actually 8. Yes. Item 37 of the following diagram, which shows a sector of a circle with center O. So this is our center O. Our center O is right here. If the length of the minor arc is PQ, so it means that from here to here, this is 8, right? Everybody agree?
Yes, sir.
Yes, sir.
This doesn't look like 8 at all. All right, so let me see if I can. Don't like to use this because I can't write on it. All right, so that's 8 centimeters, right? So this is 8 centimeters. So again, I'm going to refer back to a pizza, right? So you have a pizza, and the crust on the pizza it measures 8 centimeters. It's 1 slice. If the length of the minor arc is PQ, which is 8 centimeters, what is the length of the circumference of the circle? So again, you take out 1 slice of the pizza, right? How much was the total revolution for the pizza?
360.
360. If you take out 1 slice, which measures 60 degrees. How many slices did the pizza originally have?
48 centimeter.
Hold on. Yeah, that's the answer. But right now, the total, wait, no, this side is 8 centimeters. The total measurement for the pizza is 360, and you take out one slice which measures 60. How many slices did the pizza originally have?
6 slices.
It had 6 slices, good. And each slice, the crust measures 8. So it would be 6 times 8, which would be 48 centimeters. So the individual that said 48 first, that would have been correct. All right, good. But it's always good for you to understand what the question is asking, just to reason it out so you know that you are sure. All right, final one on measurement. The area of a triangle, we'll be able to finish. We are going up until what, 12:30? All right, so we have 34 minutes. The area of a triangle is 30 centimeters squared, and its base is 10 centimeters. What would be the height? All right, so now we can use half base times height. So half base times height is, we know, 30. We're given the base, which is 10. So half of 10 times h is 30. All right, very easy. What is a half of 10?
5.
5. So it's 5 times h, which is 30. Now we need to find out what the height is. So we're going to divide both sides by 5.
6.
So the height is 6 centimeters. Good. All right. Now we're going to be moving on to statistics. All right. So item 39 refers to the following histogram. It shows the number of children age 4, 5, 6, 7, and 8 that took part in a survey. What is the modal age? Remember,
7.
modal is the one that appears the most. This is the highest, so your answer is C, which is 7. Good. All right, so some of them you don't even have to do any work, you know, right? You just go ahead and select your answer. All right, now we're going to be getting into cumulative frequency. Item 40 to 42 refers to the following diagram, which shows the cumulative frequency curve based on the marks of 200 students who took a driving test. All right, so we're going to be looking at this. Have we ever done cumulative frequency curve before?
Yes, sir.
All right, good. So let's see. Let me see if I can zoom up this a little bit more. So sorry, so we can see it, because we're going to be using the diagram a whole lot. All right, I'll do this. I'll work with this. All right, so the first question says, what is the median mark? The median mark score by the 200 students is what? Median. Mode is the one that occurs the most. What is median?
The middle.
The middle.
Middle. All right, good. How are we going to find that? There's a formula that we can use to find the middle value, especially when we're working with curves. It is half. Is half n, and n refers to the number, the total number in the given graph. And how many students took part in this test?
200.
200. So what is half of 200?
100.
100. All right, good. So now we need to look for 100 here, but hey, we're counting by 40. So if this is 0 and this is 40, it means that halfway between it would be what?
20.
20. So 20, 40, 60, 80, 100. So 100 will be right here. Do we agree?
Yes.
Yes, sir.
All right, so here's what you're now going to do. In the examination, you'll use your ruler, and you'd use a ruler to draw a straight line. Mark, your mind might not be as straight as I want it to be.
35.
And then you're going to draw the line until it touches the curve. Then what you do is you go down. All right, so right here. All right, so now we're counting 10, 20, 30.
37.
This is 35, this is 36, this is 37. And it's actually halfway, so it's 37.5. It's between it, so it's 37.5. Do we get that?
Yes, sir.
All right, good.
Yes, sir.
Number 41. What is the interquartile range of the marks scored by 200 students? Wow, we get big words and we start to get confused, but don't be confused. The interquartile range, I think I have it here. The interquartile range is the difference between the upper and the lower quartile. Now, to find the lower quartile, it's a quarter. It's a quarter of the value. And the upper quartile is the remainder, which would be 3/4, right? So how many students took part in the survey?
200.
200. All right, so we need to find the lower quartile. The lower quartile is a quarter of 200. 4 into 4, 1, 4 into 25. So a quarter of 200 is 50. 3/4. 3/4 of 200. What's 50 times 3?
150.
150.
150. All right, good. So remember I said no, the interquartile range, it is the difference between the upper quartile and the lower quartile. So here's what we're going to do now. What we're not going to do is we're going to look for 50 on the graph. We're going to look for 150 and do the same thing that we just did by drawing lines. So the first one we're going to do is find the lower quartile, which is 50. So let's count. So remember we're counting by 20, right? So this is 20, this is 40, this is 60. Where do you think 50 would be?
In between 40 and 60.
Right in the middle between 40 and 60. So we're counting. So it means that in between here, we're counting each of them by 4. So this would be, so it would be halfway between here. So we're going in the middle. Mark your mind might not be as perfect because I'm trying to use here. And then we're going to go down right here. So it's actually in between 29 and 30. So your lower quartile here would be 29.5. Do we see that?
Yes, sir.
Hope I'm not losing anybody. Lower quartile is the first quarter, which is a quarter of 200, which was 50. So we found 50, touch the curve and go down, read that value. It's not yet 30, it's very close to 30, so it's 29.5. Let's find now the upper quartile, which is 150. If this is 120, this is 140 and 160, where do you think 150 would be?
Between 140 and 160.
Good. So it's going to be halfway between here, somewhere about here. Draw your line. And then, wait, that line is not drawn properly. Let's go again. So this is 140, 44, 48. So it's in between here. Definitely not a straight line. And then you go down. All right. So here's what we're going to do now. So this is 40, this is 41, and this is 42. So your lower quartile, your upper quartile is 42, and your lower quartile is 29.5. We're asked to find the interquartile range. And as I said, the interquartile range is the difference between the upper quartile and the lower quartile. So all we're going to be doing is subtracting. So 42 minus 29.5. What would be your answer?
12.5.
Our answer would be?
So A.
Our answer would be A, 12.5. Good. So remember, interquartile range is the difference between the upper quartile and the lower quartile, but you have to find those on the graph first. Let's look at 42, final one from the graph. If 38% of the students passed the test, what was the pass mark? 38% of the students passed the test. What was the pass mark? First, we need to find out how much does that 38 represent, that 38%. Again, percentage means out of what?
100.
So it's 38 out of 100. How many students took part in the survey? How many students took it? 200. All right, so let's go. This can go, this can go. So 38 times 2. That's 76. So out of the entire 200 students, only 76 passed. Do we get that so far?
Yes, sir.
All right, we're not yet done. So here's what we're gonna have to do. Now, because only 76 passed, we're gonna have to subtract now that 76 from the 200 and find out the amount that passed. If the amount that passed, it cannot be the lower part, it must be the upper part of the graph. So we're gonna be subtracting 76 from 200. How much would we get? 9,
124.
124. All right, good. So here's what we're now gonna do. We're gonna look for 124 on the graph. We're gonna look for 124 on the graph, and then we are going to read the information just as what we have been doing. All right. All right. So let's look now. This is 120. This is 140. How do we find out what 124 is? How much do you think each of these units represents? If this is 120, yes, they actually represent 4. So if this is 120, it means that 124 is just one place above 120. So we draw a straight line. So I'm going to use this one in green. Come all the way over and then come down. What number does it go towards?
40.
Goes towards 40. So it means that the pass mark for this test was 40. All right, 43. The following table shows the frequency of scores obtained by students in a test. What is the range of the scores? Anybody remembers what range means?
The highest from the lowest.
Good. The range is the difference between the highest and the lowest score. So this represents the scores, and this represents the number of students. What was the highest score?
10.
10. And the lowest score?
2.
So 10 minus 2?
8.
8. So easy, so simple, right? 44. I think 44 refers to the following two-way table, which shows the mode of transportation of school on a particular day by a group of 200 students. All right, so male. So two-way table means that information is coming both ways, but don't be confused. This information right here, this represents male. I'll put that in green, and I'll put female in red, and female red. All right. So all this represents male, all this represents female. Now, this information going downwards is telling you the mode of transport, whether they took bus, taxi, whether they walk, and this is the total overall. Let's now look at the question. So now we understand how the two-way table operates. Let's answer the question. A male student is picked at random. So remember now, all of this column, all of this row, it represents male student. What is the probability that he does not walk to school? So all of these are male. This represents walk, so we don't need this. So we're concerned with this information here. What is the probability that he does not walk? How many of them would that contain?
80.
80.
28 over 80.
Wait, no, wait.
80 over 200.
All right, what gender are we dealing with?
Male.
Male. So will it be out of 200? Because that would also include
Out of
female.
108.
Yes, good. So it's this part where we're contemplating. We're actually contemplating 108. It cannot be 200 because 200 will also include female. So it is 30 plus 50, which is 80 out of 108. Let's look if that is there. No, it's not there. It means that we need to reduce. Can we reduce?
Yes.
All right, what number can we use to reduce? What number?
4.
4.
All right. Can 4 go into 108, 4 into 80? We reduce, what do we get? How many times can 4 go into 80?
27.
Huh?
20. 4
27.
going to 80 20 times.
So it's 20 over
27.
27.
7. So our answer is C. Good. All right, 15 more questions now. Which of the following, let me see if I can, all right. Which of the following graph represents a function? Remember, what do we do?
A. Draw a vertical line.
Yeah, do the vertical line test like this. Good. If you draw vertical lines, it only passes through one, so A is your answer. Let's go to 46. Now we're on functions. If f of x is equal to 2x minus 1, 2x squared minus 1, and we're asked to find f of -3, we're substituting -3 where x is. Negative times a negative, that's a positive. So that's 2 times 9 minus 1. 2 times 9, that's 18 minus 1.
17.
17. Our answer here is C. All right, 47. Item 47 of the following graph. Item 47 refers to the following graph of a straight line. This is our straight line. The straight line AB cuts the y-axis at, this is our y-axis. This is our y-axis, mine will not be straight. Where does it cut the y-axis? This is our line AB. At what point? 0 and?
Zero and -2.
Here it is. And always remember you read x first, so it's 0 and -2. Here it is, 0, -2, so your answer is D.
Sir, could you zoom in a little bit, please? Thank you.
Okay. All right. Okay, good. So the straight line AB cuts y. Here is our y-axis. Here is the line AB. And this is the point that is at y. It's not only -2. Remember, it's a pair of coordinates. It's a set of ordered pairs. So it must be 0 and -2, which is D. All right, number 48. The equation of a line which passes through the point 0 and 5 has a gradient of 4. Equation of a line, what's the formula for the equation of a line? Do you remember? We did it.
Y equals mx plus c.
Y, what am I doing? Right, 4. Y equals mx plus c. All right, and we have, remember now, m represents the gradient and c represents the y-intercept. We have a set of points. We have 0 and we have 5. Which one is the x and which one is the y?
0 is the x and y is the 5.
All right, good. So all you're now going to be doing is substituting the values, right? So y is 5. Your gradient, what's your gradient? Your gradient is 4. Your x value is 0, so it's 4 times 0 plus c. 4 times 0 is 0. So it means that 5 is equal to c. Now that we know that 5 is the y-intercept, and we would have clearly seen that 5 is the y-intercept from this because x is 0. Now we need the equation. Y equals what for gradient?
4x
Gradient
plus
is 4.
5.
And what's our y-intercept?
5.
5. Very good. So your answer is
C.
Good. All right, good. And you could have also eliminated. The question says it has a gradient of 4. Look at B. This does not have a gradient of 4. This does not have a gradient of 4. So you know that these two would have been out, all right? So you know your answer would be this because your y-intercept is 5. Look, y-intercept is 5 and 5 is right here. All right, 12 more questions. Do we have the time? All right, we have 15 minutes. Think we can work with that. All right, we should be able to do this one. There was a question that we did like this morning. The range of f mapped onto x cubed. You're multiplying these numbers 3 times. What is -2 times -2 times -2?
What's here? D as in dog.
D as in dog.
Yes, that would be -8, -1, 0, 1, and 8. So good. So now that you get the concept, it's becoming very easy.
I hear me. I'm going to talk with them.
All right. Items 50 and 51 refers to the following graph of the function. This is the graph of the function, and the function is this. Y equals 4x minus x squared. Here are the problems now. The values of x for which y equals 4x minus x squared is equal to 0 intersects y at 0. We did a question like this morning. The values of x for which the function intersects y at 0. In other words, where the curve is passing through the x-axis. Where are the two? What are the two points?
0 and 4.
Right here, 0 and
x equals 4.
0 and 4. So your answer here would be x is 0, x is 4. 51. The coordinate of the turning point. Remember we spoke about turning point today?
Yeah.
What's the turning point for this graph?
2.
It says coordinate. How many values does a coordinate have?
2.
2. So where's the turning point in this graph?
4.
It's turning here. So it's turning right here. Do we agree?
Yes, sir.
So it's 2 and 4. So your answer is D. All right. Final one on this. Which of the following pairs of line is perpendicular? Now there's something that you need to know. You said C. For 52,
Yes,
how do you know it was C?
Equal to -1, I think.
All right. Yeah, you're correct. There are a few things that we need to know before we get to that though. Two lines are perpendicular if when you multiply their gradients, you get -1. Two lines are parallel. What do you think will happen if two lines are parallel? What do you think about
We get 0.
Same gradient.
Yes, two lines are parallel if they have the same gradient. So it means that B would be out. Is B perpendicular or parallel?
Parallel.
So we don't want that. That is out. So somebody said C. Anybody else got a different answer?
No, sir.
No. All right. Let's check for C to see if it's actually perpendicular. What's the gradient from this equation? The gradient is always a number that is beside the x.
4.
-4. Not just 4. No.
-4.
So the gradient for the first one is -4. What about the second one? Look at the second one. Is it in the form of y equals mx? No.
No, sir, you have to.
Yeah, we bring over 4 from 4y.
So look, you have 4y equals x plus 1. You're going to have to divide everything by 4. So y is equal to x over 4 plus of 1/4. All right. X has a coefficient of 1. So it means that what would be the gradient for this equation?
1.
A quarter.
1 over 4, which is a quarter, right?
Yes, sir.
So m is equal to a quarter. Now, two lines are perpendicular if when you multiply these two gradients, we're going to multiply these two, -4 times 1 over 4. And if you get -1, they are indeed perpendicular. Can you reduce anything?
Yes, sir.
All right, so this would be -1, -1 times 1, that's -1. So are they perpendicular?
Yes, sir. Yes, sir.
Good. So guys, remember, if you don't get it in the form y equals mx plus c, go ahead and do it like this that we just did. Get it in that form, and then you're good to go. All right, 8 more questions. All right, so now we're finished with graphs. We're now on transformation.
Hear that?
Very easy, man. Item 53 refers to what? Is this a flip?
Reflection.
A reflection.
Reflection.
All right, good.
Reflection.
All right, 54. Remember we did something like this the last time? We're now on geometry. All right, what do these two symbols mean? This one and this one.
I got 120.
So if this is 30, this side is also 30, right?
Yeah.
30 plus 30.
60.
And the
60
angle
minus 120.
120.
Angles in a triangle adds up to 180. So it's 180 minus 60,
60.
which will give you,
120.
which will give you
120.
120. All right, good. We did a question like this last week, didn't we? Item 55 refers to the following universal.
X equal
These
Y.
two angles, they are opposite.
Equal.
They are equal. They are interior opposite. So they are equal. So which one will be your answer? Which of the following best describes?
Boy.
B. X is equal to Y. Yes, these two are indeed equal.
A Z angle.
Very good. Z angle. Yeah, here it is. All right, 56. Realize when you're getting done, you don't have a lot of work, to do.
Yes, sir.
It's testing your knowledge, testing your knowledge as to what you know. Not a whole lot of work, no. All right, so item 56 item 56 refers to the following pair of similar triangles. They're similar. This side is 59 degrees. This side is also
3.5.
This side is 31. This side is 31. So they're the same triangle. One triangle is just smaller than the other.
Like an
So
enlargement.
3, yes. This is an enlargement of the smaller triangle. This side is 6. This side is 3. This side is 7. What do you think this side would be?
3.5.
3.5, which is C. Very good. All right, 57. The image of a point P, which is 1, 2, under translation is P prime, which will give you -5, -4. What is the translation vector? I'm going to work this two ways. I'm going to work it for the visual learners. Visual learners, if you want to go ahead and make a quick sketch of the diagram, go ahead and make a quick sketch. I think I have it here already.
Sir, image minus object.
It means it wants you to find out how many units did the object move from the original place, which was here. 1, 2, to get to -5 and 4. Do we see these 2 points?
Yes, sir.
All right, good. So the question is asking you, how many units did you move? Did we move from point A to get to point B? So we're going to be moving, we're going to have to move to the left. So we're going to move 1, 2, 3, 4, 5, 6 units. Whenever you move to the left, is that positive or negative?
Negative.
That's a -6. And
Or
now you're
-5.
down. 1, 2, 3, 4, 5, 6.
Oh,
What's your answer?
-6.
-6, -6. Sorry. We're here. All right, there is also another way that you could work it. No, this point, 1, 2, it refers to the original point, and this is your destination, which was -5 and -4. In order to get the translation vector, all you do is subtract whatever the result is, -5, -4, and you take it from the original point, 1, 2. -5 minus 1.
-6.
Good. You owe 4 and you owe 2. How much do you owe?
-6.
-6. We still get the same answer?
Yes, sir.
Yes.
Good. So if you want to make a visual representation, go ahead. If you want to work it this way, go ahead. It's fine. All right, 3 more problems and then we're good on time. We're very good on time. All right, item 58 refers to the following diagram. This diagram, is it a translation, reflection, enlargement?
Enlargement.
Which one is the original object?
ABC.
The smaller one.
The smaller one. How do you know the difference?
Yeah, A
Good.
the object has the one.
Prime them.
All right, good. So now here's our question. Now that we assess the graph and we understand what it's saying, let's read the question. O, A prime, O, all those points, they are straight lines. So O, A, and A prime, here it is, straight line. And this is also a straight line, and B and C is also a straight line. What is the scale factor of the enlargement? Anybody know what I'm asking? What does the scale factor mean?
How much?
How much times did the object got bigger? That's what it's asking.
2 times.
And here's what we can do. We can count a unit from the the larger triangle. So let's count. 1, 2, 3, 4, and then we divide it by that same side in the smaller triangle. 1, 2. What's 4 divided by 2?
2.
2. What if somebody wanted to use this side? It's the same thing. This is 2 and this is 1. What's 2 divided by 1?
2.
2. And if you use this side as well, 1, 2, 3, 4. 4 divided by 2 will also give you 2. So it means that the scale factor is a positive 2. You got it?
Yes.
And we have actually been doing scale factor. Remember, I had to zoom in. I had to zoom in on the graph. Remember, I had to zoom in on the graph. That was me doing enlargement. So you're doing enlargement in real life. Every day that you look on a photo and you actually do that little pinching thing and you enlarge a photo, that is enlargement. So you're doing that every day in real life. Which number are we? 59. So 59. A plane is flying in a direction of 45 degrees and then changes course in a clockwise direction to 135 degrees. The angle through which the turn took place. All right, so we can make a quick sketch of a graph, right? Do we see the graph that I have over here?
Yes, sir.
All right, so this is X, this is Y. 45 degrees, we know that this is a 90 degree, right?
Yes.
45 would be half of that, right? So let me draw a little line here. So this was where it started. And then it changes course in a clockwise direction. Clockwise, which direction is that? Left or right? It's going in this direction, right?
Yes.
And it changes course in a direction of 135 degrees. Now, if this is 90 degrees, this is another 90 degrees, so that would be 180. Where do you think 135 would fall?
Queen. Right there, so.
Remember, clockwise is this direction, so it can't be up here. It cannot be on this side. It must be down here. So it's another 45 degrees that turn you're making, so it's going to be down here.
Yes.
Ah, good. Look at this now. What angle did that make? What type
Right
of angle
angle.
did it make? A right angle. How much does a right angle measure?
90 degrees.
90 degrees. So your answer is 90 degrees. Final question. We did this. Let me zoom out now. I'm going to zoom out. All right. So final question. Item 6 refers to the following diagram, not drawn to scale, which shows the angle of depression. Remember we did this last week? I'm getting a feedback. Getting a feedback. Janelle, can we mute your microphone? All right. So, can we mute your microphones quickly as we do this lab problem, guys? All right, so here's how we go. Item 6 refers to the diagram, angle of depression. Remember we said that angles of elevation and depression, they are equal. And you can actually see the Z angle right here. And the Z angle means that they are equal. So if this is 30 degrees, this side will also be 30 degrees. All right. Now the question, let's look at the question. If X is 10 meters away from Y, which we can clearly see here, the height of YZ, here is Y, and here is Z. We need to find out the Y, we need to find here. So this is the unit that we want. So now we're doing trigonometry. This is our 30 degrees. This side, will it be our opposite or adjacent?
Opposite.
So opposite, and we have this side. So this is what we want. This is our adjacent. So opposite over adjacent. What's that?
Tan.
Tan. So your answer is A. All right. How do you think the paper was? How was the paper?
Easy, sir. Easy.
Sir, about the sending of the paper now.
Oh, finish exactly 12:30. Yes, it's a PDF document. So what I'm gonna do is I'm gonna put it in the chat. I'm gonna stop sharing and I'm gonna be putting that information in the chat. Let me see how best I can do that. All right, guys, was this session beneficial for you guys?
Very, sir.
Yes, sir.
Very, very.
All right,
Yes,
guys,
sir.
I hope that you guys understood what I said.
Thank you once again, sir.
No
Thank
problem.
you.
No problem.
Thank you.
Thanks, sir.
Thank you,
Much
sir.
respect.
Brother
Let me see
Siobhan.
if I can put it in the chat.
Brother Siobhan.
Yes, Brother Murray.
Just before you go, I want to say thanks to everyone. So just before you go.
Yes.
You are finished now?
Yes, Brother Murray, I'm finished.
All right. So I just want to say thanks to the students and I wish them all the best. And I know by their participation, I know that they have enjoyed the session and it seems to me that everybody will be successful in their exams. So I just want to say thanks to you for joining the second session because that is it for you now, right?
Mm-hmm.
All right, so we just want to say thanks to you, and I hope that everybody will be successful in their exam. So thanks much, and we will make further contact with you again. Now that we know how to contact with you.
Before they go, Brother Murray,
Yeah.
I'm trying to send it here, but I'm having some difficulties. So I don't know if Pastor wants to provide me with his email address. I can email it to Pastor and he can get it out. I'm gonna still try. So can I get an email?
You want to send it to him?
Yes, and he can send it out. Or I'm trying to put it in the chat here, but it's not. It's because it's a PDF document. It's not. I'm not being allowed to do that.
You want to send it because see my pastor is on. You can send it to Sister Murray.
All right, good. Sister Murray, do I have your email address?
Yes.
Oh yes, you just sent me. All right. So I think Sister Murray, I have your email address. So I'm gonna email it to you, and then they can get.
Now one Sister Hamilton will get it. She know how to send it out to them.
Okay, so what do I send it to you or send it to Sister Hamilton?
Me.
Okay.
Do you have Sister Hamilton's email address?
No.
Well, send it to me.
All right, so I'm gonna send it to you and you can forward it to her.
Okay.
All right, guys, you were good. I think we did well, especially with time. I think we finished we did well with the time and you guys participated a whole lot. So thank you guys again. It was my pleasure serving you. I wish you all the best in your examination.
Much class.
And Brother Siobhan, just to let
Very
you
much, sir.
that it is on YouTube and they can go back and look on it. It is taped and think they can go back and refresh their memory and some of those.
Oh
problems.
yes.
Excuse me, sir.
Yes.
I have a question. If it's not too much, I learned something today with the kill him thing.
Yes.
I don't remember fully. I don't attend their church, but it was sent in another church, and I was saying that I was going to come, and yes, it was very beneficial. But I just wanted to know what those initials meant.
Oh, like it means kilometers, hectometer, decimeter, centimeter, millimeter, and meter. So that's what that means.
Oh, because it looks like I didn't go to school that day in primary school because I don't know that one.
So when I talk about the K represents kilometer, hectometer, decimeter, millimeter, decameter, centimeter, millimeter. So that's what it means. So it's just a little acronym because a lot of students can't remember all of those. So just use that acronym to help you to remember. But I'm happy at least to remember that, so that can help you to convert very easily.
Okay.
All right, no problem. All right. I think you guys have another session coming up at what, 1?
Yeah,
Biology. All
at
right, so
1 o'clock.
yeah,
Bio.
you have like 25 minutes to go and refresh yourselves and get ready for biology.
Right, right. And for if there is anyone in Mandeville area, we are at the Kendal Church, they can make contact with us.
Okay.
Kendal Seventh-day Adventist Church.
All right. All right, so thank you guys until 1, where Sister Hamilton will come. Enjoy.
Thank you also.
You're welcome.
Thank you. Yes, sir. Thank you.
No problem.
Okay, sir. Thank you and have a nice rest of your day.
You too. I'm Andrina.
Bye.
I can't tell you what to think.
encourage you tonight because I learned faith from what Ben Fitzgerald was talking about, a praying mother. And one night, I was in my room, and we were in the middle of a situation about to be evicted. A lot of you know my story, been homeless before, but we were about to be evicted, and I heard my mom crying in the middle of the night, and I wondered what was up, so I got up out of my bed, and I went over to her room, and I thought she was, going through something was wrong. And so the door was cracked, and I pushed it open just to see what was wrong with Mom, and the crying that I heard wasn't the kind of crying that I thought it was. She was kneeling next to the bed, thanking God for his faithfulness, even though she may not see the situation changing. She was declaring, God, you're still good, and I thank you for what we do have. We may not have all that we've been asking for, but we and I declare that Jesus is all that you need tonight. I declare Jesus is all that you need. He never stops working. Even when I don't see it, you're working. Even when I don't feel it, you're working.
Nigga. Oh. No, play over this one. Play over this one, JJ. Open. Open time. It's open. It's open. Okay. make the move the kid.
Shush, hey, stop. No noise. I don't want no noise.
You are using the computer.
I'm going to turn the noise. JJ. Okay, look for him. It's hang down on the basket. To my bedside. The bedside.
What spell?
If you're not hearing me, I'll beat you. Alright. Loin.
We will come back to this session, all our students, along with our teacher for this segment. I would believe that Teacher Hamilton is standing by to take us through the session. I will turn over to her now, and she will lead us in prayer and go straight into lesson number 2.
His heart was broken, mine was mended. He became sin, now I am clean. The cross he bore my burden, the nails that held him set me free. His life for mine, his life for mine. How could it ever be that he would die, God's Son would die to save of suffering brought me healing. He spilled his blood to fill my soul. His crown of thorns made me royalty. His sorrow gave me joy. save a wretch. What love divine, he gave his life for mine. He was despised and rejected, stripped of his garment and oppressed. I am loved and accepted, and I wear a robe of righteousness. His life for mine, his life for mine. How could it ever be that he would die, God's son would die to save a wretch like me, What love divine, he gave his life for
All right, you are there, Sister Hamilton.
Yes, I'm here. Are you
You are
hearing
ready
me?
to go?
You hearing me?
Yes, you are ready to go.
Yes, I'm going. Yes, I'm ready to go. I'm going to share my screen.
All right, just before you share your screen, I just want to welcome everyone, and I just say thanks to you and those that have joined, all the students, and I just want to have a word of prayer, a very short prayer, so that I know that God will help them, and I know that based on their response from the last time, they will be successful in their exam. So I just ask them to give me just a few seconds as we pray just before we begin. Father in heaven, we give you thanks, Lord, for your blessing. We give you thanks for your care. We give you thanks for all those students who have joined on this platform to further educate themselves and get answers pertaining to their exam. So we ask you to take charge of them. We ask you, Lord, to take charge of the one who will be giving guidance in terms of tutoring these students. So we ask, Lord, to continue to be with them and that they will be successful in their exam. In Jesus' name we pray. Amen.
Amen.
All right. Thank you very much, everybody. Thank you very much, Sister Hamilton. And you can go right ahead.
All right. Are you sure you're hearing me, Brother Murray?
Yes, I am hearing
All right.
you.
I'm not. Yeah, because my speaker is saying your speaker is not working, so I'm not quite sure.
It is a little bit low. I don't know if it is a bit low. So if you can do anything on your side.
All right, I'm okay now.
Yes, you can go ahead.
All right. Good afternoon, everyone. All right. So what we're looking at today, we're just going to look quickly at genetics, the test cross diagram, the Punnett square. And I'm sure you have a lot of persons, knowing that it's a multiple choice paper, you're wondering probably how the questions will come. But you just need to ensure that you study, know your information, and you will do just fine. Now I'm going to share my screen. I'm going to ask, let me see the persons who are on. Selena, open your mic. I'm not seeing a mic for her. Adrian Williams, open your mic.
Yes, miss.
All right, hearing me well. All right, so I'm going to ask you just to keep the chat. Just go to the chat for me. Monitor the chat for me. All right, tell me if you're hearing me, you're seeing my screen.
No, miss.
All right, hold on.
Well, it starts to share now.
All right, tell me when
yes,
you
I'm seeing.
All right, good job. All right. So I'm hoping everybody, you're seeing my screen. Adrian, you're seeing it properly, or I need to zoom it a little bit more?
I am seeing it properly. I don't know about the others.
I'm expecting that if you're seeing it, everybody else would see it too. All right, so we're looking at gene. What is gene? What are genes? And so there are certain terms just before, there are certain terms that you need to know. And we just only have until 2, so we need to go through quickly. All right, so we're looking at genetics. You need to know the term genetics, all of that. Genetics is a study of heredity and the variation of inheritance, inherited characteristics, right? Example, such traits are seen in like your eye color, your skin color. Those are what we're referring to. So it's some terms that you must know. So if you're studying genetics, the first thing that you need to know are the genetical terms, right? Now, moving on. So all of those, I'm not sure if anybody wants to write them. We don't have the time to write them. I'm going to ask the persons who need a PowerPoint to go to the chat and write your names like the last time. Write your names and your email address, and then we'll send them to you. Last time we sent the multiple choice paper to the persons who requested it. So we'll do the same. So you don't need to say you want to write off the slides, right? All right, variation is a term used to show that there is a difference, right? There's a difference. There is a difference between individuals of the same species. These variations differences may vary in physical appearance or mental differences, such as personalities, right? So they're going to be variation. And so you have different types of variation, right? Have different types of variation. I'm not sure if you're seeing the slide, or probably I'm going too fast, but it's just a refresher, so I'm expecting that most of you would know that information already. All right. Now, when we talk about genotype, phenotype, these are some words that you must know from heart and can relate to them. When we talk about genotype, what's the meaning? Somebody, quickly in the chat, give me your definition of genotype. Yes, Adrian, I'm seeing that the chat, we have 16. I'm not sure if it's questions or persons 17 now. What are they saying in the chat, Adrian?
Miss, they are sending their email addresses for you to send the PowerPoint to them.
All right. I asked a question. I need your take on what we believe genotype is. Anybody answer that question in the chat?
I don't see nobody answering.
All right. So we said that it's coming in?
Emails are coming in, not answers.
All right. So guys, just pause a bit and let us have an interactive class, right? I want you to get the term. So when we talk about your genotype, it's a part of the genetic makeup of a cell, right? Therefore, any individual, so for every individual, we talk about genotype now, it's the genetic makeup, right?
All right, Mr. Some answers are coming in.
Yes?
Some answers are coming in. Ashley says that characteristics passed down through gene. And next person, Alexandra, said genotype is a genes determining a person's characteristics. Genetic, she says genetic makeup.
All right.
Those are the response.
All right, those are good answers. Good. So we talk about the genotype. We said this is genetic makeup. All right, fine. We talk about genotype is the information contained within the 2 alleles. All right, those are perfect. So we have another term that you must know. We have genotype and we have phenotype. Can we differentiate between those 2 words, genotype and phenotype? So the words seem similar because you hear the word type at the end. Now you have the phenotype, and it tells you that the phenotype is what? Is the physical or observable expression. So your phenotype is what you can look at, right? Ready now? I want you to pay attention. So on the phenotype, so I'm able to see you. So I'm able to see you, Adrian, right? Is what I can look at is your phenotype. So if you have brown skin, or if you I can see your eye color, which is brown or dark brown, those are your phenotype, what I can actually see, right? The physical characteristics. Now on your genotype, right? On the genotype, it's different. The genotype, you're not able to see what is on your genotype. Let me explain. So it's there, right? It's there, but it cannot be, it's like, it has to be, for example, you have homozygous and heterozygous. Do you know those terms? Do we know those terms? Chat, write it in the chat. Do you know those terms?
Persons are saying yes.
All right. All right. All right. Yes.
Yes.
Somebody explain. Anybody explain homozygous for me? All right. I see that person's there. Read for me, Adrian, what they're saying.
Heterozygous is two different alleles.
Right.
Persons are saying
Wonderful.
that homozygous are same alleles as well.
All right, wonderful. Those are correct, right? So homos, you said they are same, and heterozygous, they are different. So we say we have alleles, we have chromosomes, we have genes. Those terms you must know. Now, you would get one gene from mommy and you would have one gene from daddy, right? Pairing, right? One gene from mommy, so we talk about the skin color. You have one gene from mommy, so you have brown skin from mommy, right? You get that allele from mommy, and you get so you get dark skin from daddy. Both of them will be there on the locus, right? Now, what will be seen on your phenotype is the one that is dominant, right? That's what we're saying. So in the genotype, yeah, both of them is in the genotype, but what will be seen now is what we call the phenotype. So which one is dominant? Is it that I can see you and that I can see that you're brown skin or you're dark skin? Whatever I can see, I can physically see, that is actually your phenotype. Now, you always hear a person saying that, you know, two black persons have, you know, have a brown baby. How that possible? That must be jacket. Have you heard that before? So think about it. If you have a recessive gene, right? A recessive gene, right? Both of them have a recessive gene. And remember, you know, on the genotype, it's there, but you can't see it because it is recessive, right? It's there, cannot be seen because it's not shown on the phenotype. So there you have two black persons now coming together. You have two recessive allele, right? Two recessive allele coming together now, which now is going to be shown now on the phenotype. Do we understand that? Need to see your answers so that we can move on. So you get those two words properly. If you know those two words now and you can understand those two words, we can move on. You understand genetics. So the diagrams, yes. Everybody saying yes?
Understand.
All right,
yes.
Wonderful. Let's move on. All right, so we talk about now differences between continuous and discontinuous. Remember, we spoke about earlier variation. We said variations, they are different. So we have two types of variation. We have continuous and we have discontinuous variation. And you have to know the examples when we talk about continuous and discontinuous. All right, it's there in the slide for you. Can read that for you. Continuous variation, the differences are slight, right? Continuous, slight, and merge. Right, so really and truly, you can't really continuous, right? You can't see the difference really, right? And you have example. While discontinuous variations, the differences are vivid, right? You can see it, right? And you can see that like in tongue rolling, most of you probably could roll your tongue as example of discontinuous. Also, another example would be like in cows, horns, you would see that the parents would have horns, but when they pass it on, right, the offspring wouldn't have horns. So that would be an example. While continuous variation, no, you have skin color, right? Skin color, those. Good. Another example for discontinuous variation would be your finger, your fingerprint, your thumbprint, right? That's another example of variation. And those things, guys, you just need to remember those. So know the definition of continuous and discontinuous variation and can give your examples. Those are factual things and they will ask you, right? They will ask you those and they can do come in multiple choice. So don't take it for granted, all right? All right, moving on. All right, so they ask now, what are genes? We said that they are genetic information. So genetic information is passed from parents to offspring in chromosomes. And with last class, we spoke about chromosomes when we were looking at the multiple choice questions because they ask you what are chromosomes. You need to remember we said that chromosomes, they are thread-like, they're within the nucleus of the cell. Remember when we were looking at the plant cell, animal cell, when we look at the nucleus of the cell, you have to remember that. So we said that the genetic information is passed from parents to offspring in the chromosome. So that's how you get your special characteristics from your parents, right? So chromosomes occurs in pairs in the body cells. So that chromosomes occurs in pairs in the body cells. What am I talking about? All right, in human body cells, we have 46 chromosomes. I'm sure you know this, right? And you have other terms for it. You have 23 that was going to be given by mommy, and you got 23 from daddy. So the sperm cell would have 23 chromosomes, right? Right? And the ovum would have 23 chromosomes. Good? When it comes combined in fertilization, then that's where you would get the grand total of 46 chromosomes, right? So 23 chromosomes are from the father, which are paternal, while others, 23, from the mother, which are term maternal, right? We get this? So that's how you ended up with your 46 chromosomes. Now, the other species would have different amount of chromosomes, right? But we're talking about us now. Man, in general, we say that we have 46 chromosomes, and they will say autosomic and somatic and autosomatic cells, right? So you have body cells. So what you really need to remember right here now, guys, what you need to remember. Yes, Jasmine? Go ahead. Jasmine, I'm seeing that you raise your, have a question? Go ahead with your question. You hearing me? Adrian, you hearing me?
Yes, miss, I'm hearing you.
Oh, I guess probably that was a mistake then for Jasmine. What is important here that you must know, guys, right here, you must remember that the sperm, the egg would have 23 chromosomes. See, 23 chromosomes. And we're talking about the body cells now. The body cells, regular body cells, would have 46 chromosomes. So going, just to reiterate, so the sperm, right, would have 23. The egg would have 23. When you have fusion, yeah, fertilization taking place to form a zygote, then that's where now you'd have the complete amount of chromosomes in your body cells. That is 46 chromosomes, right? Moving on. So that's what you need to remember. All right, so this was a term that we asked earlier, and yes, you gave your answer. What are homozygous alleles? And yes, you answered that correctly. Our genes, which are the same, right? And guys, remember now, we use the letters of the alphabet, right? To show this, to demonstrate it. So for this one, it could be 2 lowercase b, for example, if I'm using B, or you could use 2 uppercase B, right? To show, because remember now, it's there in pairs. So 1 from mommy, right? 1 allele, 1 from mommy, 1 from daddy. Good. Moving on. All right. So this is where we were talking about now. Dominance in allele. No. If the alleles are different, one may mask the expression of the other. No. So, Adrian, are you seeing my cursor?
Yes,
Going
miss.
around? All right. So we said that if the alleles are different, all right, one may mask the expression of the other. Good. Now you are seeing here where we said that this is homozygous, the B. So you have to pay attention now. You have to look on the screen. So in this case here, you have 2 uppercase B, and we said that that's homozygous, right? Now, right at the top here, we say that one may mask the expression of the other. For example, in the heterozygous form, right here, you have capital B and you have a common B right here. Now, if say that you have a capital, anytime you have a capital, the capital one is what is going to be seen on your phenotype, right?
That's
So that's
heterozygous.
Yes, heterozygous. All right, wonderful. All right, so this one now, right? The capital B would mask the lowercase one, which is the recessive one. So the capital one is a dominant one, and the common letter here, common letter B here, would be the recessive. Yes? Go ahead.
It's the recessive, yeah.
Yeah, okay. All right, thank you. All right, so I'm sure that you're supposed to understand this one, right? Now, I'm going to give you a question quickly. All right. All right, let me move on from here, and then I'm going to give you 2 questions, and I want to hear your answers from the questions that I'm going to give you to see if you're really and truly understanding. All right, so you must understand homozygous and heterozygous and to know which one is dominant and which one is recessive. Because to go on now, you need to know, right? All right, moving on to the diagrams, the genetic diagrams. I hope you're seeing the genetic diagrams here, right? Now here you have tall and you have a dwarf, right? We're looking at a pea, a tall pea, right? A pea plant. So genetic diagram for the first cross, tall pea, right? And a dwarf. Now what we use here, just as when you do in math, you have, I think it's matrices.
The Punnett square.
Yes, you could use a Punnett square for this one, right? But this one is not a Punnett square, no. So we can do both of them. You can do a Punnett square.
And cross multiply.
Yes. Yes, so cross multiplication here would be like your matrices that you would have, you would have done in math. Now, what we start with, guys, again, you need to state sometimes before, because not now, you won't see this on sexy for now. But if you're going to do so that you're going to do a long paper, you would see that it is 8 marks or 6 marks, and you're wondering, so how they give you that little thing, and there's, you know, how are you going to get all of those marks? No, you have to start just as in math. You're going to say let capital T equals, yeah, capital T equal tall, all right, and let common T equal dwarf, right? So I understand what you're saying, right? So capital T meaning tall, and then you have dwarf, which is common T. So for a dwarf, you'd have to have 2 lowercase t, and that's what is seen here. So for tall, 2 capital T, which is dominant, and then the dwarf now would be the recessive 2 common T's. Good. Now, here now we're going to be putting them back down single file, because we want to now go and cross multiply, just as how you would have done it in matrices. Now, this long T, this first T here, Damani, you talking? Damani, you saying something?
The ratio will be 1 to 4.
All right, so let us do it then, Damani. Let us do it. Let us just do it first, so that the persons who didn't understand and they asked for the class, let them just get a little chance to do it. So let us do it together, and then I will give you one to do. Right? Now here, this T, this one, I pay attention, ensure that you're looking. This T, capital T, and this T, right? You're gonna put them together, right? Across multiplying. So right here, that first, this one that you have here, you're seeing, I hope you're seeing my screen. Let me see if I can fix it a little bit better. All right. So this is where, so you have this T, cross multiply. So this is where you got those. Right, so you have a capital and a common, capital, common, and this now we know the genetic terms, so we can start using the genetic terms here. We have a tall P, yeah, we have a tall P plant here, right? But we can start now in saying that this tall P is a carrier of the dwarf gene, right? This tall P here is a carrier of the dwarf gene. Then you're going to have this T coming down here and this T, right? That's how you get this one. And this is also a tall P. It's a tall P again, and it's also a carrier of the dwarf gene. Now you're going back to this T now. So this T and the first T over this side again, so you cross multiplying, right? What you do to one side, you're going to do to the other. So this side, this T coming down here, and this T coming here, and this is also a tall T, and they're also a carrier of the dwarf gene. Are we getting that? So the ratio here, yes, go ahead now, Dominique. Dominique, you're saying now the ratio here would be what?
1 to 4.
All right, so you realize that all of them would be tall, right? All of 1, 2, 3, 4. They would be tall pea plant, right?
Yes, miss.
Yes, because they all have a dominant, right? They all have a dominant T, right? But let us do this one. Everybody will do this one, and you're going to tell me the answers. You're going to show me, I don't know how you're going to do it, but you're going to do so I can see it in the chat or possibility. I will let you do it, and then you just open your, I don't know if you can open your camera. You can open up your camera? Yes, I think so. You open your camera, write it on paper, and show me to see that you're understanding. So let's go. Now you have, and listen to what I'm saying keenly. Ready? No, two heterozygous from what I gave you before, 2 heterozygous pea plants. Tell me their offspring, the ratio of their offspring. Use a genetic diagram to show this. So for the persons who would have known before, your Punnett square, you could use a Punnett square, or you could use your test cross. By the way, use the test cross only. I'm going to assume that you don't know the Punnett square. Let us go again. What you're going to be doing, you're going to use a genetic diagram to plot 2 heterozygous pea plant, right? 2 heterozygous pea plant, right? Are you going to do this on a sheet of paper? I don't know if you want to just do this so I can see it. And I'm going to look in my participant now, and I'm going to just take like 4 persons just to show your screen. Alexandra Hanson, yes, you're raising your hand.
Miss, I'm asking why is the ratio 1 to 4 since there is none of them that would be short?
It would be 1 to 1, right?
Okay.
It's 1 to 1. Is it? I understand what he's saying. He's saying that he's going to put 1 over 4 times, you know, to give it a percentage, right?
Okay.
All right.
Okay.
All right, Alexandra, I'm going to take you first. Hello? Yes, go ahead. Go ahead. Good evening. Yeah. Oh, I'm on the marathon right now. I call it. Yeah. Ready, Alexandra?
Yes, Miss, do I have to draw it or could I just draw it while I show you, or could I just show you what I've drawn?
All right. I'm not sure if you can, what you're going to be. You open your screen. Open your camera.
I am about to do so now.
All right. Do it now and let me see what you have.
Okay. I think it should be on.
Hold on. Damani, Damani, just wait a bit, a little. Yeah. Let her let me
Can you
take
see the
Alexandra.
screen?
Yes, I'm seeing you. I can see. I'm not seeing your paper yet. Yes, go ahead.
Oh, okay. And then that is to that. Sorry, I made a mistake. My eraser does not work very well. Maybe I should just redraw it. Yeah.
I'm not seeing the paper doing it, Alexandra.
You're not seeing it?
I'm seeing. Hold on. Let me see if I can erase. I'm seeing the ceiling.
Oh, I thought I had changed the camera. Can you see it now?
Yes.
Okay.
Go ahead. And you're using a test cloth?
A test cloth?
Yeah, you're using the diagram, the genetic diagram?
Yes, I am. Sorry, I didn't know that was what it was referred to as. I was taught the Punnett square.
Okay.
In terms of the ratio of dominant, for the ratio, am I comparing what is dominant, what is recessive,
All right,
and
so
what
are you going
is...
to tell me the amount of tall plant that you have, and the amount of short, and the amount of of carriers do you have with the dwarf plant?
So I have 3 tall plants to 1 short plant, and then I have 3 plants carrying the recessive dwarf gene to 1 dominant plant, completely dominant plant.
Right. Bring your camera a little bit more down. Let me see. Let me see. No, I want to see. Yeah. Try it. Go over a bit. Let me see.
Is that better?
Yes.
Okay.
And there's a capital T and a common T, a capital T and a common T.
Yes. And then you have two homozygous, which is one that is dominant and one that is recessive.
All right, so that is only one. So one plant you would have, that is, we said that's a dwarf. You have a dwarf plant there?
Yes, completely dwarfed. Yes.
All right, so that's one. All right, good job.
Thank you.
All right. Dominic, your turn.
There is one like it, miss.
I'm not seeing you. I'm not, oh, hold on. I'm not sure if it's my thing that what I did. I know. All right, Dominic, I'm not seeing you again. I don't know what I did with the Are you showing? Yes, I'm seeing you now. Good. All right. So now Dominic did. Everyone, you can make sure you pay attention here. Dominic did a test, a Punnett square. I'm seeing a Punnett square. But Dominic, you answered the question that I asked, though. I'm seeing at the top where you have two capital T's and and at the side you have two common T's. That's what you have, Dominic?
Yes, miss.
So I asked though, the question states that you have two heterozygous coming together. So you're not answering that question, Dominic. That was probably the question that you did previously. So the question, oh, you have a second one? Yeah, Dominic, what is important here? You would have to remember that you have to put heterozygous simply means heterozygous. You would have to use a capital T and a common T. So where you have at the top, touch the top for me, Dominic, where you have two capital T's at the top. Change one, the second one to a common T. And let me see again, I'm not seeing it in your paper. And then where you have the two common T's to the side, you're going to change one and you're going to make it a capital T. So change the first one to capital. Normally, I would make sure my dominant is in front. I'm not seeing you again. Good. So what I'm going to ask you now to do, Dominic, can you cross multiply those now? Do over that question and tell me now the ratio that you would have for tall plant and dwarf. You're moving your phone, so I'm not able to see. All right. So yes, first one is correct. Second one, yes, is correct. Yes, good job. What would be your ratio now, Dominic?
I should probably write.
Dominic, what's your ratio? So now, Dominic, we know that even the ones that just the ones with a carrier, they are also going to be tall. So you're going to count up now, Dominic. 1, 2, 3. So that was what's going to be 3 tall. So write that down at the bottom. So 3 tall. Right underneath the Punnett square. 3 tall. All right. And then you have 2 common T there. So that would be 1 short or 1 dwarf. So the Dominic, just as in math, what you would do, you would write beside the tall. You want to do the ratio, so that would be a 3 to 1, right? Yes? All right, suppose I ask you the percentage, what's the percentage? Everyone, this is for everyone. What's the percentage of short would you have? What would you tell me?
25%.
25%. How you get your 25%, Shante?
because the ratio is 3 to 1 and the 1 is short. So when you divide 100 by 4, 1 out of the 4 that you divide by is 25, and the 75 would be the 3.
Wonderful, good job. So it's
Each
1
of
over
them
4.
represents 25.
All right, yes. So 1 over 4 times 100, all right, to give you your 25%. Good job. All right, so you need, Dominic, I'm going to ask you to continue to practice. Let us see how far, if we can still do some practice, but we need to move on to another part of genetics before the time is up. All right, thank you. All right, moving on to this. So I am expecting that, I'm thinking that most persons would understand this and I can move on. Let me see, everybody, Adrian, everybody, can I move on? Say yes, Adrian, tell me what they're saying.
Yes, Miss. You have one person asking if would the genotype ratio be 1, 2 uppercase T to 2, 1 uppercase T and a lowercase t to 1 lowercase t.
Go again, take your time. Let me write what you're saying. Go again.
Yes.
If the genotype ratio would be what?
The first 1, 2 uppercase T, 2 capital T, to 2 capital T and a common T, to 1 and 2
And that
common.
they were, all right, so that they're trying to answer the question that I gave before. That's what they were trying to answer, Adrian.
I think they're asking a question because the person said, would the genotype ratio be?
But if they're asking a question, the question must be related to a question that I gave before. Who is that? Let the person open the mic and ask the question.
Jordan, Jordan Brand, Sterling.
Brian, Jordan, can you explain what you're asking? Yes, go ahead.
The ones with the tall trees versus the dwarf trees.
The ones with the tall trees?
1 short. Yes, 3 tall to 1 short.
Yes, 3 tall, 1 short. Yes. Yes.
So
but remember now, Jordan. Oh, so even though we mentioned before, Jordan, that even though they are carriers of the dwarf, remember they have a dominant gene same way, so we'd have to still say that they're tall because it's what is expressed on the phenotype. Remember that, Jordan?
Yep, I remember that.
All right, so when we are looking at it now, what we are asking now is a question you have to look at, and this is you must pay attention to this. The question that we're simply asking is the amount of tall plants, right? Amount of tall plants to dwarf. So we know that for dwarf, for you to be full dwarf, as in can be seen that you're a dwarf, you must have 2 recessive genes. But now you have a tall, a capital T, and a common T. That means you're still tall, but you are a carrier of the dwarf gene, right? Thank you. Can we move on now? Any other question there, Adrian?
No, miss, there are no other questions. Somebody saying, yes, I understand better now.
All right, thank you, thank you. So let us, because I would want to go into another, like your genetic diseases, right? And I know some students, they are so, we want to look at sex-linked disease. Let me see if I can reach to that point. All right, so here you have a diagram again showing you have normal, so this person is a carrier, right? 2 carriers, and this is the same thing that I asked before, right? And Adrian asked me to explain this before. So here, the 2 capital coming together, this person, you realize this person would have 2 capital A's. So this person is not a carrier, this is quite fine. This is a quite fine person, right? Even though when you're a carrier, right, you're okay too. It simply means that your offspring, if you have an offspring with a carrier, then there's a possibility, right? There's a possibility, there's a chance that the carrier would be full blown, depending on what you're looking at, if it's dwarf, right? So here, this person is a carrier again. This one here is a carrier, and then this one is affected, right? This one is affected. And this this is for in every case. Every case possible, this is how you would have your genetic diagrams look, right? Moving on. Explained that part already about homozygous dominant and heterozygous have the same phenotype, right? So moving on. Am I going too fast? Want to get to another genetic diagram. All right, moving down to the genetic diseases. I want to look at Albert, right? This one is a what? This is a genetic disease too. All right. Can't cover all the slides, but I'm going to do another diagram. All right, let us just go back up. Looking at dominant, codominance, right? We're looking at the flower plant now. Flowers. All right, flower color is in some plants, such as the impatient plant, all right, shows incomplete dominance of the alleles. This means that there is a blending or a combination expression of both alleles in the heterozygous condition. All right, what am I saying? This also occurs in man, so I want you to pay attention here. In codominance, there's an expression of both codominance. Is the word co? Same way in English, right? What's the meaning? There is an expression of both alleles in the heterozygous gene, thus creating a unique combination and variation in the production of the offspring, right? So now, for in man, so looking at man, we can look at man to say that you have blood groups. We have different blood groups. So we have blood groups AB, and O. So you have A as one, you have B as one, then you have a codominant now where you have AB, right? And then you have O, which is another blood group. But the codominant one here is the AB that is together. Do we understand that? Do we understand that? No, AB blood group would be the universal recipients, right? What am I saying? Universal recipients simply means that AB can receive all the other blood groups, right? All the other blood groups AB can receive. No, A group can only receive A and O. And why they can receive O is because O doesn't have any antigen, right? Antigen on it. So O can be also. So if I said to you, Adrian, sorry to be using your name all the time, but say that I say that Adrian, right? Adrian, I said that you are A blood type. So your blood group is A, right? Your blood type is A. No, you don't, yes, you know that your blood group is A. That is what is seen on your phenotype, right? That is what is shown on your phenotype. But if you are going to want to know what is on the genotype now, Adrian, then you will have to do, something further to know what is really on your genotype, right? So it simply means that if you're A blood group, Adrian, it simply means that you can be only AA, 2 capital A, right? Or AO. Are you getting that? Everybody?
Yes, miss.
So if I say that you're A, so you say that I say you're A blood type, it simply means that you can be only AA or AO. Are you getting that? Then now,
Yes,
I go on
miss.
to say, I can give you a question. But before I give you a question, let me go on to B blood group. B blood group, it simply means that you can be BB, 2 capital B, right? Or BO. Because remember now, B can only receive B blood group or O. And remember we said that O, we call O the universal donors. O can give to all the other blood groups, but O can only receive from O. Get that? Get that? So O, they are the universal donors, but they can only receive blood from O. So that's the part with O. Now AB now can receive from everybody. AB can receive from everybody, right? AB can receive from also O, right? So if you're AB, we say that you're AB. Now let us ask now, using the AB, we're looking now, we're going to use this to plot, right? To plot a graph. Not a graph, but use a genetic diagram. So on using a genetic diagram, ready? Next question. From the information that you got, make sure you understand the information perfectly before we move on. So you understand the information that I gave you. Everybody, yes? All right. Now I'm going to ask you, use a genetic diagram. Use a genetic diagram. To show the offspring of heterozygous A group, and homozygous B group. So those are the two persons blood group that is going to come together. So heterozygous O group, B group, A group, and homozygous B group. Do that for me and let me see if you understand the term heterozygous, homozygous in this case. So I said heterozygous A and homozygous B, right? You're supposed to be working.
Excuse me, Miss, I have a question.
All right, go ahead.
Miss, you were saying that one of the blood groups were showing codominance and incomplete dominance. Which ones were those?
No, so codominance, right? Codominance, not
Okay.
incomplete, but codominance. AB.
Okay.
All right.
Thank you.
You're welcome. Are we finished? Yes, no, maybe so. Adrian, are you finished?
No, miss.
All right, seems like this one is a little challenge, man. Didn't get this one? Let me see if you want me, all right, you want me to do the first one, then I ask you to do another one? Let me see, say yes or no in your chat, and let me just do this one for you, and then you want to move on to do another one, because I want you to understand this. If this is the last thing we'll do, I want you to understand this before I leave.
Correct, Miss, persons are saying yes. They want you to
they want me to. Oh, it simply means that they didn't get it. All right, let's go. Ready? Dominic.
Yes, miss.
All right, show your, oh, yes, Dominic. Dominic, show it, all right, wonderful. All right, keep it there. Everybody, let us look on the screen. Look at Dominic's screen, please. Pay attention there. So we said that it was heterozygous A, heterozygous blood group, and then you'd have homozygous B, and that's perfect, Dominic, you got that correct. So that would be your first 2 marks there. Now we're going to start plotting. Okay, So you have AB, so AB first for the first one. Yes, that's right. Then you have A and AB again. So you have AB, so 2AB. Then you have AB again. And then you have, hold on. Is that, Dominic, is that AO or AB you have at the first one?
It's AB, miss.
No, the first one here. I can't see. Is it AO? Is AO you have or A, capital A or common A? Which one you have?
Capital A, then common A, miss.
All right, that is where you go. You went wrong there. All right. All right. Yes, I'm seeing it better there. Keep it there. Now, remember now we say, guys, I gave you a formula. I gave you something that you must follow first. Everybody, listen. You only can have AA or AO. So, Dominic, what you are supposed to have there, the first part there is AO. Good? Not A, not capital A and common A, but AO, because I gave you the thing to say that when you have an heterozygous A group, it would be AO. Remember we said that? So I'm going to ask you to change now. Dominic, change it now and write AO at the top there. Same way, yes, change the A. Yes, put O right there. Wonderful. Get that? That's the only mistake because I thought that was an O. Good? All right.
Yes,
and
miss.
the BB that you have, put it back, I'm not seeing it. All right. And the B and the BB that you have is perfect now. Now, the part that you made a mistake now, Dominic, you'll have to fix it. So you're going to change all the others now to O at the bottom, right? You did that already.
Yes, miss.
Right? And so that would be the correct answer. That would be, so you'd have AB clotting, yes. Then you have AB again. Then you have OB, right? And OB. That's what you have?
Yes, miss.
Are you sure? Can you do that on a Punnett square for me, please?
Yes, miss.
Turn a page, turn a different page for me, Dominic, and you do that. So students, you're going to have what you're going to be plotting, everybody, right? Start writing. Everybody start writing for the persons who did not understand. Ready? So the first one that you're going to have, because I asked you about heterozygous, you're going to have AO. Good? So AO on the first side. So those would be AO. Then no, you're going to have 2 capital B's to the other side. Then no, you're going to be plotting. So AO and 2 capital B's. Then you're going to be plotting now the offspring to see all the offspring, right?
Man, can't keep your baby no, man.
I'm sure by giving you the alleles, everybody's supposed to can plot it for yourself. So what you're supposed to be getting now. All right, wonderful. Bring it up a little bit more. All right, yes. All right, good. Normally we put the A, we put the A before the B. You hear, Dominic, we try to practice that. I know some teachers say that it's fine, but I try to put, because we say AB blood group, we don't say BA blood group, so we put the A before the B. Here, Dominic?
Well, I heard that it's the same thing, miss.
Yeah, man, it's the same thing, but because we're doing we're looking at codominance, we don't have a blood group by the name of BA. We call it, AB. So that's why I'm saying.
Yeah, I know what you're talking about.
All right, wonderful. So that would be the correct answer. Adrian, everybody
Yes,
know,
miss.
answer in the chat. Can we move on and to do one for yourself? Everybody?
Yes, miss. Yes,
Sure.
miss.
All right,
Yes,
yes.
miss, we can
All
try.
right, so let us do a quick one. Let me find one. Let me find a sexy one and see if you guys are ready for it. Just give me 1 little minute. All right, ready? You have to pick, listen now, listen. Listen, 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 listen. A baby has blood type B. A baby has blood type B. His mother had blood type A. You get that? You have to, guys, this one is a little bit of thinking, you know, so don't say, Miss, I don't understand. You have to pay it. So no, full stop. His paternal grandfather has blood type A. It's paternal. And we know what paternal means. Paternal grandfather has blood type A. And his paternal grandmother has blood type B. Determine no. Question no. Determine the genotype of the baby. Determine determine the genotype of the baby and the possible genotype of the baby's father. So going over. So you're going to determine 1, the genotype of the baby, and 2, the possible genotype of the baby's father. When you get that one, no, we can finish for today. Pin. All right, we're working. Anybody finish yet? Just ask it. Are we finished? Adrian, anybody saying anything in the chat?
Somebody's just respond. They're saying no.
All right, good. I'm giving you some more time.
Miss, answers are coming in. Somebody saying
All right.
B.
Somebody saying B, but you can't just say B. What is that, man? You'll have to tell me. Remember, you just can't say B, no. Remember, we're looking at what they ask you for. You're looking at the genotype now. So the genotype now, you'd have to tell me if it's 2B, if it's a BB, or it's a BO, or you have to show me your diagram. So the person who is coming in, who is that person? Give me that person's name and let they.
Rochelle.
Rochelle? Okay. Rochelle, open your mic and show me your diagram that you used to come up with, you came up with all of this. Yes, Rochelle?
Come in.
All right, wonderful. I'm giving you some more time. Anybody else?
Miss Alexandra said the baby would be BO.
But Alexandra need to show working. Remember, it's gonna be 6 marks, Alexandra.
Miss, I know, but
right, so
my working
yeah.
is very confusing. I don't even think
All right,
Miss,
fix it
I'm
up.
not
Fix
even
it
sure
up.
it's
We have the
correct.
time. We have the time. Fix it up, Alexandra. Fix it up. Come on, fix it up. Ready? All right, still giving you a little bit of time, man. Adrian, nobody else in the chat? That one holding you, man.
No, miss. Nobody is at the chat.
All right, we have to work with what we have, though. You read your questions carefully and to remember the thing that I gave you on the table. The table is still there. So if you're A, simple means that the person can only be AA or AO. Mommy must give you one, daddy must give you one. So if I'm O, daddy has to give me one, mommy will have to give me one. So what is daddy's? Which one mommy gave me? Which one daddy gave me? Do you understand? That's a little, you know. That is a part of it. So make sure you pay attention. So write it down. Write what you know. Go with what you know. We know that the baby is B and the baby's mother is A. Remember it says A. So if the baby's mother is A, simply baby's mother can only be what? If she's A, she can only be AA or AO.
Or AO.
Right. Right. Wonderful. So if you find out that one already, so guys, you have to think about it.
If the baby is BO, then the father would be B.
Ah, you're coming there, man. You're getting it. So yeah, but you can look, you know, Adrian, remember they gave you what is the daddy's grandmother and grandfather's type, you know. And if the baby,
oh yes,
so then that is it, you know, guys. You're paying attention. You're just looking at the baby B, but remember, grandma and grandpa would have to give daddy what daddy has. So you should just simply just go to the grandfather and grandmother, and then you would actually get what daddy has, and then automatically, because we know what mommy has already. Mommy has A, so that means the mommy could never. All right, I'm not going to tell you.
But Miss, I have a question. Isn't there like 4 possibilities that you could combine for the grandmother and the grandfather, because you could
4
use
possibilities.
AO? Yes,
All
Miss, you
right,
have
so,
AO, you have BO, and then you have BB and AO, and then you have BO and AA, and then you have the BB and the AA
all right.
together.
So but you have to look at the father. What's the father? They're asking you what's the possibility now of the father. So you're on track. So you will have to first know, Alexandra, come down now and try to plot now the grandmother and grandfather. That's what I'm looking at. I want you to do first. So put the possibility now and start using now. Can they ask you the possibility? The possibility.
So
Miss Russell is saying,
Alexandra, you're on it. Adrian, yes, Adrian, tell me your reasoning. Just give me a possibility, any one of the possibilities, as long as you ending up with the baby being B, that's your answer. We said possibility is not a definite one that we're looking at. So tell me your possibility, but show me using your genetic diagram. Let's go. Ready?
They don't have the proper internet or whatever, they would physical class.
So Miss, I think I've come to a conclusion. The father is BO, and the mother would either be, she could either be AO or AA, because when you plot it, you would.
Hold on, come again. Come on.
Wait, Miss,
So
give me a second.
yes.
Give me a second. I'm going to
All right.
fix it
All
up so I can better say it.
Okay, okay. And be careful because I heard you say, I wanted you to repeat.
Miss,
Lisa,
I
come
think
here.
the mother is AA and the father is BO.
All right, that's Rochelle?
Yes, miss.
Rochelle, you said that the mother, as in the baby's mother would be AA? That's what you said, Rochelle?
No, miss, wait, miss.
All right, Rochelle.
Miss Davis' mother will be A or AO. Well,
No,
AO.
but look, I want you to be definite. I want you to, listen, I want you to tell me definitely, and you know
Okay,
why,
Miss.
you can back it up, yes?
Miss, I think I have it now. So I agree with the young lady that spoke before, who said that the mother would be AO and the father would be BO, because if it's BB and AA, right, you're going to end up with all of them being AB. And if it's AA, and I guess she could be AA also, because if you have BO and AA, you will still have the possibility of having a BO child, but the mother can be you don't know. I take it back. I don't know.
Alexandra, you were saying it so perfectly before, but I don't know where you went wrong. Everything was fine. This is the first 3 lines that is the answer for it. So the part that you came now with the back part here with the mommy, let us go again. Alexandra, remember, the baby is B. Mommy is A. Mommy don't have no. Yes, so mommy must definitely be. We know definitely that mommy must be what?
AO. She has to be AO.
Wonderful.
She can't
Good
be AA,
job.
because if she's AA, you will only end up with AB and AO as your possibilities. So she has to be AO. The father has to be BO.
What?
So.
Exactly. You're wonderful. I love that. Good job. Everybody, let me hear the other persons. You see, Rochelle, can I speak to you, Rochelle? Rochelle,
yes,
you're getting it now, because listen, Rochelle, I want you to reason a little reasoning now right here. Mommy, remember, mommy, we said that mommy is A, and mommy have a baby that is B, and we know that the baby is mommy's, not true? But if you're going to say that mommy is AA, that means that mommy couldn't have that baby. That baby would definitely be somebody else's baby. Do you agree with me?
Miss, I get
mommy would have to. You're getting it now?
Yes, miss.
Wonderful. Adrian, what about you?
Miss, I kind of understand.
All right, I guess possibility you would have to get you would have to get some more practice, right?
Yes.
To get some more practice, but always remember, guys. Remember, I'm gonna leave this with you. Always remember that mommy will have to give one, daddy will have to give one. So if you don't see the possibility where mommy giving you one and that means it's completely incorrect, right? So you have to remember, mommy give one, daddy give one. So if mommy one is not there, you'll have to change the entire equation. You get that? So that is what you have to look at. And sometimes we have I'm going to ask you guys, go on YouTube, go and look at a pedigree, the pedigree chart. The pedigree chart will allow you to help you to understand all of this. So I'm going to ask you, please, go and read up on your pedigree chart. Go on YouTube, look on the pedigree chart. This would allow you to understand more.
So, Miss, I have a tip for the for figuring out what the father is, because neither of the parents could be AB. He would have to be BO, so he couldn't get BB at all. So the only one you'd have to worry about is the mother.
Alexandra, you're getting to be a pro at this now, man.
Thank you.
Good job, good job, good job. All right, everyone, nice having you. I'm going to leave now. It's now 2:19, but nice to have you. Wish you all the best on your exam.
Yes,
and I know you will do well.
Thank you, Miss.
Miss persons are sending their emails, so I guess I remind you not to forget to send.
All right, let me see. Normally, I would have a student from my class. Let me look at the chat. Hold a bit. Let me see. I can stop this now. Stop sharing. Let me go to the chat. How am I going to get this now? I'm going to copy it. I don't have anybody from my class today. All right, I have it copied. I'm going to put it in a. All right, guys, so what you could, all right, so I have all the, all right, I have all the names. Let me see if it was, all right, guys, so do you want to share your numbers? So that, all right, you want me to share my number with you. And so if you have any challenge or you want to ask me a question further after you go and do your reading, you can get me on that number. Or the exam is August what? August 6th?
No, Miss, August 3rd.
3rd? Oh, you remember 6th. You're right, 3rd, yeah. All right, some persons share their numbers. Right, I have everything from the channel. All right, guys, so I hope you will do well. See you another time. I think your physics class is in what? I'm not quite sure if it's today. I don't think so.
Physics is Wednesday.
It's Wednesday, Miss.
All right, Wednesday. All right, nice having you guys.
All right, and thank you very much, Sister Hamilton, and thanks to all those students. I wish them all the best. We have already prayed for them since morning, so I know that they will do good.
All right, then. See you another time, guys.
Thank you, Miss.
You're welcome. Oh, all right, you're sharing your numbers. Hold on, guys. You're sharing the numbers. I didn't get the numbers. I want to get the numbers. All right, I have to go back and copy the paper again. All right, Tyree's wrong. All right, let me just go back and copy all those numbers. All right, anybody else sending numbers? I'm copying it so I can save the numbers. So if you're sending the numbers, send them quickly.
Realize, sir.
I can come back now, Jason. Come. This robot is M. The robot is not
All right, I have everything now. All right, guys, bye.
Come and fix it. See there?
What about this one?